Welcome, Pythonistas. We've all been in this situation. We want to make games, so we sit down and start coding. But then slowly the rot sets in. Maybe we make a mistake here or there. Point is, before we know it, the codebase has become cluttered, to the stage where we would have to put in significant amount of work to reshape it. Don't be scared, this will happen to good and bad code alike, but there are some strategies we can use to help manage our codebase as it grows from a script to a system. My name is Andrew, and you can find me on YouTube as Get Into Game Dev, where I make tutorials on game development and graphics programming. Welcome to Pygame Summer Camp. This camp picks off where my last summer camp left. Pygame Summer Camp Sugar Smash covers the basics of working with Pygame and making a Candy Crush clone. The final project for this camp used some pretty cool algorithms that don't normally get taught in beginner courses, so I'd strongly recommend checking that out. The purpose of this camp is to step beyond just coding and to think about the bigger problem of code design. Of course, we will be learning some new coding tricks, but overall the focus will be on software engineering, making readable code that slots into the whole system. The final project will be a Final Fantasy clone, which I'll call First Fantasy. With that out of the way, check your bags in at the door, and welcome to your next Pygame Summer Camp. As we start to make bigger games, we'll want to use files to save and load our state. Imagine we want to load a game from a text file. This file could include all sorts of information formatted in different ways. Although larger developers typically encrypt their files, as an indie developer, and to save our sanity, we'll just go with a plain text format. Later on down the road, if we want, we can write tools to edit our levels, but the level data will still be readable and debuggable. In order to add some structure to our game level, we'll segregate the data into sections marked by headers. These headers are metadata. Their purpose is to describe the data so that our program understands which section it's reading. Let's now jump over to our code and see how we could read this data in Python. Alright, so let's get into it. We look at this level1.txt and we can see that we have a bunch of different sets of data, and each set of data is declared starting with a header, which is indicated with these square brackets. Okay, so how do we load something like this? Well, we could read this in line by line and have it all processed in the one function, but I want to split this into separate functions which handle loading different types of things. But perhaps we're getting a little ahead of ourselves. I'm just going to run through a few preliminaries. So see that I've got this open in Visual Studio Code. You can use any editor that you like, but for me, VS Code is just the right blend of functionality, and it's good, it's nice. We'll make a file, main.py. Now you see down the bottom, I'm using Python 3.10. Really, any Python 3 version should be fine. 3.8, 3.9 is fine. Currently, Python 3.11 has been released. Apparently, the performance is pretty good, though there are some compatibility issues with other libraries. 3.10 works just as well for me. Okay, so first thing I'm going to do is I'm going to declare some stubs. Okay, let's go with some stubs. So make a function called load file. It's going to take a file name, and I'm going to make a type hint. And I'm going to declare a return type. In this case, absolutely nothing. That's fine. And I'm going to put pass there. Now that pass is a It's sugar, basically. It's just a stub saying, yep, I understand this isn't going to do anything right now, but, you know, just cut me some slack. Don't give me errors about it right now. I'll come back and fill that in later. I'm also going to make a main function, which takes nothing and pretty much does nothing as well. Okay, then I'm going to declare a entry point. The way this works is with the conditional statement. There we go. Now, this main has nothing to do with this file name, main, and has nothing to do with this function, main. All it's doing is asking, was this file clicked on? See up the top, I have this run button executing this current Python file. There are two ways to work with Python files. One is to directly execute them, and the other way is to import them as modules. So just to demonstrate that, by the way, run this right now and see that it prints out you ran main. Okay, awesome. So that is directly executing this file. Now what we can do is we can add another file. This will be a little side file, and I'll just go ahead and import everything from main. So I've imported everything from main, so I should have access to all of these functions from the other file. So we can go load file, blah, who cares? Okay, so the point is we're using the things defined in that other file. But just to be sure, let's go print you ran side and run that and see this conditional statement is verifying that side.py is the file which was executed. Even though we've taken everything from main, including this entry point, and imported it, it's this conditional statement which verifies that this file is the one that we physically clicked play on, if that makes sense. But anyway, that wasn't the main point of this session. We can delete that side and carry on with it. Okay. Now you may notice that throughout this session I'll be starting and stopping quite a bit. The reason for that is that I don't want my computer to seize up and for me to have to re-record everything. And this is probably a good point in time to say we should be saving our work often as well, because you never know. Okay, so what this conditional statement does is it is a wrapper around the main function. And that's fine. That's fine. So what am I going to do here? Let's go ahead and load this file. Now we're going to need to provide the file name, which will be data type string. So there are two benefits to declaring type hints. The first benefit is that this load file, I may have imported it from another file, another module somewhere, and I don't want to have to dig around to different files to see what the parameter types are. So having this pop up for me is really useful. Another reason that I like VS Code. Just load that one there. And then the second reason is if I got rid of this and just said, hey, we're going to take some file name, then Python doesn't really understand anything about file name. Look, I hover over it, it says, yeah, that was a parameter that came from the bracket, and its data type is just any Python object. So there's no IntelliSense. When I try to access this, there's nothing. On the other hand, if I declare that this is a string data type, then I hover over it, it tells me, hey, I expect this to be a string. So then when I put a dot, I have access to all of Python's string functions. And it's useful. It's just useful. So now let's get into opening and closing files. There's a function called open. It takes, and it says file, it's a bit weird. It's actually gonna provide the file name. That's a string. And then we have this mode. Now, there's a few options here. Basically, R is for reading, W is for writing, and then we have A for appending. We also have, I believe, B for binary, if we want to load a binary object as opposed to a text object. We're not going to do that, that's fine. Now, the difference between writing and appending. If I open something in write mode and it doesn't exist, then that file is created, and then anything I write to it, there it is, gets written to it. If it does exist, it's completely blanked out, and then what ends up there is just what I write. In other words, it resets the file. However, if I do this in append mode, then it will write. If the file exists, it will write onto the end of it. It won't reset it. But really, I just used read and write. Now, see here it says this returns an object. It returns a text I/O wrapper, text input/output wrapper, which, yeah, we should, I mean, that makes sense, right? When you open a file, you need to get the object that you can work with. So I'm just going to call this file. And then if we pop in here, there's a whole bunch of things that we can do here. I'm just going to keep it simple. So I'm going to go read lines, and I'm going to print that out. Run that. There we have it. That is looking good. So what is this doing? Well, it looks like we're printing out a list, and each item in the list is a line in the file. And we can see that as well, because if we hover over read lines, see that it returns a list of strings. Okay, that makes sense. That's what we're printing here. So there's one more thing, and that is, we're being a bit bad here. What we should always do is close the file after we're done working with it. It's best practice. What about if we don't just want to read all the lines at once? There's a few cases here. Case number one, the file may be really big. I mean, yeah, okay, my computer's got 64 gigabytes of RAM. No text file is that big that it'll be an issue, but it is something to think about. And then, more importantly, what if we want to read one line at a time, read a line, make a decision, read another line, make another decision? It's a better idea to do that. So what we'll do is read a line. Now, if we hover over here, we see that returns, whoops, a single string. And then let's keep looping through until there are no lines left. A good way to do this is to say while line, and then do what we want to do. Okay, so this is super important, this last line, otherwise it'll keep going forever. Now, Python has what's called true-like values. That is, for each data type, some value of that will generally count as true, and some other value will generally count as false. With a string, a blank string counts as false, and a non-blank string counts as true. File read line will return a blank string when the end of the file is reached. So what this does is we grab a file, we grab a line. Is that line empty? No, okay, print it, get the next line. Is that line empty? Yes, it is. Okay, we reach the end of the file. While loop ends, and then we have it. So we can run this and compare to the file. I mean, we've got these extra new lines, but that's fine. Yep, we are successfully reading the file one line at a time. Okay, so we're reading it one line at a time. Now let's handle these header files. What I'm going to do is I'm going to read a header file, a header line, I mean, check what type of header we're working with, and then throw that file away to another method which handles that sort. So I'm going to have another method to load the creature data, another method to load the player data, and so on and so on. But before I worry about that, I'm going to need to work with this. So I'll say test, let's say test the first character of the line. The headers start and end with square brackets, so I expect the first line to be a square bracket and everything between those two to be the header type. So we'll say the first character should be square bracket, and if it's not, then we want to throw an error of some sort. Okay, so it's a good idea just to run this. Yep, okay. So the first line says creatures. There we go. The first line is the creatures header, okay. The next line is bat. Bat does not start with a square bracket, and so we have thrown this exception. Okay, that's looking good. Okay, so let me just run through this. What this line is doing, actually, let me just get rid of that for now. So what we can do is we can grab everything starting one character in and ending before, one character before the end. One character away from the end, which should be everything including just creatures, just getting rid of the square brackets. But see that there's an extra square bracket. So to get around that, what we do is we strip off from the right. That is, there's usually a trailing new line character, and this will get rid of that, and then split that further down. So if we run that, now we've just got creatures. Okay, that's looking good. Okay, so now I'm going to write some code to handle the different cases. Okay, cool. So I'm actually going to get rid of this bit here where we say line equals, actually, no, I won't do that yet. But in the final version, I will get rid of that, because what I want to do is I want to make a function which takes the file as one of its arguments, continually reads through it, and then returns the next line after all of the data in that section has been written. So I guess we'll get to that in a second. And what else was I going to do? Let's make another file as well. Oh, I totally forgot this. Let's get to it now. So all of this, like explicitly opening and closing the files, doesn't necessarily have to be done. We can scope the file to a block. So we basically go open this, declare it as file, and now for the lifetime of this code block, the file exists, and when the code block ends, the file will be closed. So again, as you can see, I open this up, and then it is scoped to the lifetime of this code block. When this indentation level closes, then the file does as well. And we can actually open multiple files in the one line. So I'll have this output file. Go through all the work here, and then write the status out there. Okay, cool. So let's go ahead and make the stubs for these creature, player, and player items. Okay, so we know that this is going to return the header, the next line after all the creature data. So we know we're going to return a string. What we want to do, if possible, is declare the data type for file. So again, if we go up to this open, see that this returns a text IO wrapper. So it sort of complains. And the reason it oh, really? Let me try this. Okay, so we've imported the text IO wrapper from the input-output module. Now we have that. Okay, so we can test that. Oh yeah, we can read line just as before. So this is an indicator that the acceptable acceptable type for file has been found. Okay. So what we can do is we can say line equals okay, cool. So we've got all of those, and this will be very similar. Read the player data, read the inventory items. Cool. So they do their thing, whatever they need to do, and then they return the next line after that stuff has been read. So we can close that for now. Okay. So what are we going to do? Well, for the creature data, we're going to keep going while that line is valid. We can actually get rid of this bit here now as well. So one thing we want to do is we want to check, we've just read a line from our file, is it the next header? Like, have we gone one step too far? The way we can check that is look at character 0 and say, is that a square bracket? If it is, what should we do? Well, we should return that probably. Let's go ahead and do the same thing for these ones. They're all going to work the same way. Okay, so let me just bring this over to the side. Now let's have a look at the bat. Now, what I want to do is I want to basically split this. And I want to split it around the opening bracket. So there's a number of things we can do. One of them is called partition. Now let me just put this in. I want to, oops, I'm getting this wrong. Okay, so I want to put in the thing that I want to split and the character that I want to split around. Let me just print that out for now. Okay, so it's going forever and ever. But as you can see, it's returning a tuple. The first element of the tuple is the thing before the line split. Actually, let me just change that. That makes sense, right? We should progress to the next line. Okay. So, as you can see, we return a tuple. The first element of the tuple is the thing before the delimiter. The second element of the tuple is the delimiter. And then the third element of the tuple is everything after the delimiter. So we can actually unpack this. We can say, okay, the name of the creature, and then something. The arguments used to create it are this one here. Now this underscore indicates that this variable will not be used. It'll just be thrown away. I mean, we don't need this open bracket. That's fine. And then we can go ahead and split this again. And this is basically just throwing away, basically just grabbing everything before the final bracket. Another thing we can do is see we have these spaces inside here. Some of them have spaces, some of them don't. Let's just get rid of the spaces. Replace space with blank string. And then I want to split. So basically when I do this, I'll get a string with no spaces, with the numbers separated by commas. So I want to split based on the comma. See, this will return a list of strings, and those will be each of the individual numbers in this case. Now let's test this. Let's just go print. Yep, okay. Yeah, that makes sense. That is each of the arguments there. Okay, good. So now I want to test, basically, do I get a valid name for my creature? I'm going to declare up the top. Actually, I'm going to declare a few things. I'll go ahead and do that now. So hopefully you can see how these relate to the file, just basically checking for valid input. So with the creature, we've either got bats or cats. So it's not in creatures, then we want to raise an exception. Okay, cool. So if it is one of the creatures, then yeah, it's either a bat or a cat. So we'll have some helper functions for making those. We can go ahead and declare all of those. I'll just pop down to the bottom and actually make those functions, and then I'll call on them. Okay, cool. So yes, nothing too exciting. We're just doing simple print statements just to verify that we're passing through the data properly. There we go, and I'll use that other function later. So these are just some helper functions that I can call on. Okay, so we'll just bring it back up to the creature data. Okay, so see we need to give X, Y, and health. So this will follow the order of the arguments. So we want to put in argument 0, something like that. Now I just need to match this to the data type that we expect. So I expect x to be an integer, y to be an integer, because these are strings at the moment. We need to convert them into number types. And then the health will be a float. Okay, cool. Otherwise, we'll go ahead, we'll make a cat. So again, for the cat, x is an integer, that's argument 0. Y is an integer, that's, argument 1. And then argument 2 is already a string, so we can just pass that in as it is. Okay, so we'll give that a go. Yep, okay. So just double checking, we made a bat at x equals 12, y equals 2, 23.6 health. Okay, yeah, okay, I'm pretty happy with that. All right, so let's have a look at the player. Okay, so we're done with the creature data. Now we'll have a look at the player data. Now we have this function down here, make player, which takes in all these things, all these fields, and see that these fields are being declared one line at a time. Okay, fair enough. So what I want to do is step through this, save the data when I see it, and go from there. So I'll just put in some placeholder data. And then similarly, I will partition the line. So that is the semicolon and the space, as we can see here. The left side of that is the property that we're setting. The right side of that is the thing that we are, the value that we want to have there. Now we want to test this. We're going to go if property is not one of the player properties that we declared up above, then raise an exception. But otherwise, we are fine. So then we want to check, is it a name? Okay. If it is, then set that name variable to the value. Otherwise, cast it to a float. Good. So this loop will be going through, and when it sees a property, it sets the property. But we want to have another exit test there, and that exit test is if none of them are none. Okay. So I'm pretty happy with that. Let's run that and see how that is going. Name player 1, health 75. I'm pretty happy with that. Why is that going to a new line? Because player 1 may have a new line character in it. Let's just right strip that out. Try that again. There we go. Okay, good. Good. So again, we saw the creatures header. We jumped into the function to load the creature data. We see the player header. We go ahead, we load that. Now we get to the player items. Now, let me just close that. Okay, so if we look at this items data, what do you reckon this would mean? Some lines just have one thing, some lines have two things. We can sort of gather that this line means that we have a short sword, and these other lines are giving us the quantity of each of these. Okay, so let's go to the inventory items. Now I'm going to store the Yeah, I'm going to store the inventory in a dictionary. That's fine. Okay, so before we were doing fancy partitioning things, here we're just going to do a simple string work. So we'll go right, strip out that trailing new line. Then I'm going to get the arguments by splitting based on a space. So see, that's why I have an underscore here on short sword, because otherwise it would count as two different things, which is a little bit weird. So first of all, I want to know whether my line has one word in it or two, and I can check that by looking at the length of the line, or length of arguments actually. Okay, so this is the case where we've just got one word like short sword and we're just declaring that we have it. So what we can do is turn it into, basically this is turning it into a line that says short sword true, basically. Because remember, split returns a list of strings, and so we can append something there. This is slightly dodgy. I mean, no, that's actually, it's not. It's not, because we have a string and then, anyway. So we have okay, cool. So again, what this append is doing is it's making sure if the line has one word in it, then we'll add an extra word as if it was a line with two words. Thing is, though, we control that word. Then what we do is this item type is going to be the key in the dictionary, and this status is going to be the associated value. So if we had like a bow or staff, then the associated status would be true if that's something that we're now carrying. And it's easy enough to check if that is in the dictionary later on. But then if we have a two-word line, then the word potion would be the key, and the status would be the string that says 3, or something like that. Okay, cool. So let's run this. And we can see that we have the dictionary that says short sword true, potion 3, antidote 2. And yeah. And as a matter of fact, I'm just going to add another bit here because I don't like that it's a string with an integer. So what we can do is, if we have a two-word line, convert the second argument into an integer. Yeah, okay, pretty happy with that. So there we have it. This was our little whirlwind tour of working with files. Hopefully you can see how you could adopt this to your own system. And yeah, have fun with it. And yeah, I'll see you again in the next session. So we can read and write text files. Let's take things up a notch by looking at images. The goal of this session is to read an image from a file, apply a few basic transformations, and then blit it on the screen. We'll also be looking at taking screenshots. So let's get into it. So here we are. If you go and download the code for this whole course, head to folder number 2, images, and then the start point, the start folder. We have this graphics folder, and inside this graphics folder, we can get rid of that. That's fine. Inside this graphics folder, we have this skeleton boy over here. So what I want to do is basically load this image in, do some transformations to it. let's head back and we'll open all of this in Visual Studio Code or any development environment you want to use. And we might get a little message here saying select interpreter, so we'll go ahead and select the interpreter. And that should be fine. And let's get into it. So what do we have at the moment? This is almost the most basic Pygame environment we can have. It's just a simple loop which pretty much does nothing. So we set up Pygame, we initialize it. Again, this is covered in the Sugar Smash course if you're not familiar with initialization, Pygame or anything like that. But basically we just pass in the screen size and we go to set mode. See here it says, whoops, it says it's returning a surface. Now a surface is a custom class inside Pygame, and it basically is a whole bunch of pixels. It's just an array of pixel data, and there we have it. So we set up this loop. This loop will keep going forever and ever until a quit event, and that is basically the user clicking on the X. In that instance, this while loop will exit because running is set to false. So what we do every time is we fill the screen with the background color and then we flip the screen. So if we run this right now, it's filled with that background color defined over here, mostly blue. And when we hit escape, that is the quit event. So the first thing I want to do is I want to load an image. So we'll just load this here. And the way we load things is we have Pygame, and then there's an image module inside that, and then the load function. And we need a file name. Okay, no worries. So we'll just pop over. We have the folder graphics and then skeleton.png. So we'll put in here graphics skeleton.png. Okay. Now, it says that this returns a surface, so we'll need to store the result into a variable. Let's just call this image. And there's another thing we need to do. It's a good idea to convert this surface into the native surface for the Windows format or the windowing environment, and this just speeds up the blitting later on when we draw it to our screen. So see, we have two functions, convert and convert alpha. Convert is just the regular, is what it says, and convert alpha is for images which have any sort of alpha component. That's fine, we can just convert that. Now let's do this. We have screen surface, we fill that, and then we want to blit onto that. So the way this works is we're blitting one surface onto another. So let's blit the image. And we also want to, what is it? We look here, we have source, which is the thing that we're blitting onto it. The thing that we're taking the data from to blit onto the screen. And this does not have a default value, so we need to specify something there. Then we have destination, and this is the region into which we are blitting, which is either a tuple of integers specifying the top left corner, or it could be a Pygame rect structure, which is basically a more descriptive way of describing where we want to blit. But this doesn't have a default value either, so we need to specify a destination. And then we have area, and this area is if we only want to blit, say, some of the source. But this does actually have a default value with this equal sign, and this specifies that we actually don't need to put anything in here. Similarly, for special flags, this has a default value. Doesn't say what it is, but that's fine. So we don't need to specify that. So the point is, let's specify the top left corner. So I'm going to, where we put this? Let's specify this here. So So we'll say it doesn't matter. Let's just go completely in the center. So 320 across, 240 down, and specify that there. Okay, so let's give this a shot. Very interesting. So first of all, see that the top left corner is in fact in the center of the screen. But there's the issue that the image is really big and it's too big for the screen. So we're going to have to apply a transformation. Probably a good way to specify this is to specify ahead of time what the sprite size should be. And I'm just going to come up with this off the top of my head. So double the height compared to the width. That's fine. Okay, so what I want to do is I want to make, I want to scale this, but let's say I don't want to touch the original image. It's common practice to load an image and then take a copy of that with transformations applied so that we're not messing with the original image. That could, I mean, it's not the worst idea, but if we apply the transformations in place, they're non-reversible. So it's a good idea to have the original data. So I'm going to call this transformed image. And the way we apply this is we go into the Pygame library, if I can speak. There's a transform module inside there, and I want to scale. So if we look at this, the first argument we take is a surface. That's a surface that we want to scale. So we're going to scale image. The next is the size, and that's where we can put in this sprite size that we specified. Then destination surface. Now see, this does return a surface, and I guess we also have the option of, instead of using the return value, passing in a third argument, which is modified in place, but it has a default value of none, so let's just not even think about it. So let's take that transformed image and blit that onto the screen. And there we have it. Now we have the size. It's a little it's a little off. We could probably change the position a little bit. As a matter of fact, let's do that now. So let's go. Let's put the skeleton right on the bottom. So if the top left is at a height of 480, that will be right at the bottom of the screen. Then we will subtract the skeleton's height from that. I could be a little neater with this, but this is fine. And there we have it. Skeleton is on the ground. Okay, so what are some other transformations we can apply? Well, let's spin the skeleton around. In order to do that, I'll just specify a variable called t, or time. So a parameter there. And I'm just going to increment this every frame. So what we'll do is increase, time by a little bit, and then modulus under 360, just so that after a full revolution it comes back. So I'm going to apply a transformation stack. So see, we've applied one transformation. If we go Pygame transform rotate, then we want to rotate the transformed image sprite. We want to, for the angle, just go T, and this returns a surface. So we can save that there. Give that a go. Oh, okay, so it's spinning. And yeah, we could control the timing a little better. We can make a clock. But the big thing I want to look at is see that as the image spins around, the rectangle around it is resized. And because the anchor typically is the top left corner, then results are unpredictable. Of course, this would look better if we had an alpha channel instead of a white channel. But then the skeleton would still be spinning around like this. We just wouldn't be able to visualize the rectangle. So what we want to do is recenter the image after spinning it around. Things tend to spin around their center, so here's what we can do instead. So we rotate this, and then get the rectangle of that. And the way we do that is we take the transformed image and then get the rectangle. And we'll just leave that there for now. And then instead of the skeleton position, we'll pass in the transformed rectangle. Okay, so this makes sense. We no longer are setting the top left corner, but we still have the same issue. Actually, we're almost there. So what we can do is we can pass in a keyword argument. So we get the rectangle, and then we set the center to a certain value. We go 320, 480 minus 256. That's a little better. It's not quite on the bottom, and the reason is originally we were looking at the top left, which would have a height of 256, but if we're looking at a center, the center has a height of 128, so we'll just pass in half of that. And there you can see, yep, the skeleton is spinning around in place. So this is sort of an esoteric thing when we do it for the first time, so I'll step through it again. What we did is we rotated the image and then we recentered the image. So we specify, yep, I want to get the bounding box and center it around this coordinate. So that makes sure that things don't get weirdly shifted around. Of course, the white background looks weird, but if this was an alpha channel, it would look perfectly fine. So that's one sort of transformation. How about color? So I'm going to specify something else. I'm going to specify a tint color that I want to apply to the whole image. And I like to use sine and cosine when I'm animating or automating simple parameters, simply because they're repeating functions. So I'll import the math library, but I'm just using this to generate a tint color. So if I take 128 plus 127 times sine, well, math sine. Sine goes between negative to positive 1. So at one extreme, we would have 128 minus 127 is 1. At the other extreme, we'd have 128 plus 127, which is 255. And that's pretty good. I'm happy with that. So I'll just convert that to an integer. That will be the red component of my transformation of my color. And I'll just, yeah, why not? I'll just put 0 for the other components. So this is specifying the tint color that I want to apply to my image. How do we apply that? Well, what we do is we fill the image. So we go transformed image, fill, and then I'm going to say, okay, for the color, we'll put in tint. For the rectangle, we don't need anything, but in order to make sure that we're not just overwriting the data, I want to specify a special flag. And that special flag is if I go into the Pygame module, blend, and let's multiply. So as you can see, it's just modifying the red channel, and it's repeating. Actually looks pretty cool. I've got to be honest, looks pretty cool. There are other options. Let's go max. So see there, the white is already greater than the red, but then the black parts flash red. I don't know. I think this looks cool. So we're applying geometric transformations to images. We're applying per pixel transformations to blend the colors and things. I'm sure you can imagine in an RPG game, if a character gets hurt, you might want them to flash red. If they get poisoned, you might want them to flash green. Those are the major colors, right? Okay. But another thing we might want to do is take a screenshot. So let's have a look at that. I'm just going to add some other parameters here. Let's go screenshots taken is 0. This is just so that every time I make a new screenshot, I'll save it to a new file. Let's go here. So in the events, we'll go if the event type is a key down event, so basically if we hit the space. Now we want to save this. Now if you look back above, we have Pygame image load, and that returns a surface. So I guess maybe we'll go Pygame image save, and that takes a surface. Okay, so the surface we're going to take is our screen surface. We're going to save all the pixel contents of the screen surface, and then we have the file name. So for the file name, I'm going to use an F string. I'm going to make it screenshot. And then we'll insert the screenshots taken variable. So the first time it'll be screenshots 0, screenshots 1, screenshots 2, and so on. And then we'll just increase that screenshot count. Okay, cool. So give that a go. I go space, space, space. Okay, so I should have 3 screenshots, and if I look at my folder, yeah, I do. I have 3 screenshots. Now you may say, what is the benefit of taking a screenshot? Well, imagine you're playing Final Fantasy or Pokemon or something, and you walk along and then you trigger an event. It would be really good if we could take a screenshot, then read that screenshot back and apply post-processing effects to it. I know OpenGL, you can do that without taking screenshots, but this is Pygame, and I'm not doing OpenGL in this one. So yeah, hopefully that was fun. Learned a few things. It's pretty cool. Pygame is cool. All right, see ya. All right, so in the last video, we looked at basically loading images, working with surfaces. Some of these early videos are going to not be completely connected, but they will link up a little bit. The next thing I want to look at is something called Sprite Groups. Now, in our game, we're going to have a whole bunch of objects, and we can write our own routines for dealing with the objects. However, Pygame gives us a class called a Sprite Group and a class called a Sprite, which gives us a more succinct way of organizing things. We don't have to use it. We can make our own systems. In a lot of more complicated games, we'll end up making our own systems anyway, but it's just a good thing to look at, and in a lot of cases, it might be enough. It might be good enough. So to start with, I'm just going to make an environment where we have a player and we move the player around with the arrow keys, and there are some boxes that it can't. The boxes block the player's movement. So we'll have a whole bunch of boxes and we'll be doing collision checks. As we can see right now, this is just the basic starter code that I was using in the video before. We can run this, and it doesn't do a whole lot. We've just got that blue background, and we exit. Okay, so first of all, I'm going to do this without any sprite groups, and then we'll add those in. So what we'll do is we'll just run line by line. The first thing I'll do is I'm going to use the random module to randomly make positions for all my boxes. Then here I've got some named constants. I'm going to add another named constant to that. That's probably fine. As you know, Python doesn't have constants, but we can indicate that these things should be treated as constants by writing them in block capitals. And you can see out the front, the linter, the code checker, indicates that this should be treated as a constant. Okay. So what else do we have? I'm going to make some status codes. Now, we could use a string to describe the status code, but this method is it's a little more lightweight because a string can actually store a lot of data. And in C, it's common practice to use enums or, enums to indicate flags, so that's what I'm going to do here as well. It's also common practice to indicate the scope of the constant in the name. It just makes it a little more readable. So we have those codes, and then I'm going to make a dictionary that we can use later on to look up the different block colors. Now, any block that the player is not near to is going to be inactive, and that will be a sort of gray color. And then anything the player is close to and colliding with will count as active, and that'll be a lighter red color. So as the key for the dictionary, if the block is inactive, we'll go 192 on each of the components. So nice gray color. And then if the block is active, the associated value for that will be, we'll just go max out the red component, keep everything else the same. Okay, cool. So those are our named constants. Then we're going to have two classes. We're going to have a player class and a block class. These player class and the block class are going to share a lot of data in common. We could actually use inheritance. Now, this is just my preference. I like to avoid inheritance a little bit. I think it gets a little bit, it's not that bad, it just gets a little bit convoluted, and why not? Okay, so for the initializer, we are going to need to take an X and Y. And let's go ahead and save those. And while we're at it, we'll set a width and a height as well. Okay, now I'm going to make a surface to represent the player. And here we're going to need to specify the size. I'll just hard code this. That's okay. Okay, next thing I'm going to do is make a function which returns a rectangle representing the player's position. Now, the way a rectangle works is we can just create one. So we go return Pygame, make a rectangle. Now, as you can see here, we have 4 parameters that we need to input to create one. The X coordinate of the left, the Y coordinate of the top, the width and height of the rectangle. So we actually can work these out. So let's say that this XY that we've stored here is the center. So what we can do is we can take the X coordinate and subtract the width, subtract half of the width. That will be the left X side of the object. Then if we take the Y coordinate, subtract half of the height, that will be the top. Now remember, depending on how much experience you have, this could be weird or familiar. Y equals 0 is the top of the window, and Y equals whatever is the bottom of the window. So subtracting the height will get us back to the top of the rectangle. Then for the width, it's simply self width, and for the height, it's self height. So there we have it. Okay, now let's move. Okay, so we have this amount, and this amount stores two components. It stores the movement in the X coordinate and the movement in the Y coordinate. So let's unpack that. That is, we go dx comma dy equals amount, and that unpacks the two components of the tuple and puts them into those two variables. So what I want to do is I want to adjust x. I could go increase it by dx, but then we need to check the boundaries. And there is a more succinct way, or a more compact way to do this, and that is a min-max test. So we clamp this, we say I want the minimum of either, whoops, we'll go screen size Okay, so I'll just run through this. Let's say that dx is positive, so we're increasing our x coordinate. Then we say, well, what is the largest that our x coordinate can get to before the rectangle starts to go off of the right side of the screen? Well, if we take the 0th component of screen size, that's the screen width, and then we subtract from that half of our width, right? Because that's the padding that our rectangle has before it goes off screen. Then this is the absolute largest that our center x coordinate can be. So that's the min bit, now the max bit. What do we want this to be bigger than? Well, it has to be bigger than 0. But then, again, remembering that if our x center is at 0, then we're actually going off the screen. So instead of that, just take the half of the width. Okay. Then we can do exactly the same thing with the y. And yeah, there we have it. We have moved it. Then the last one is so there we have it. So yeah, although we do not, so I'll just, this should be obvious, but I'll go through it. The surface is the Pygame surface that we want to draw the player onto. So the way we call this is we'll say, hey, draw the player, and I want to draw the player onto the screen surface. Okay, fair enough. Now we don't really have to fill the image every frame, but for instance, if we had an animated image or we had something which we expected to change very often, would be a good idea to do it every frame. And then we simply blit it on. This rectangle is specifying where we want to blit it on the surface. Okay, cool. So Now I'm going to basically redo this to make the block class. Actually, you know what? I'll leave the block class for now, and we'll just get the player walking around. Okay, so we'll go down to the main function. What I am going to do is I'm going to make a clock object. And the purpose of that clock object is basically controlling the frame rate. So I can call tick to update the clock, and then here I'll pass in the frame rate that I want to limit the program to. And this just makes sure that things don't go incredibly fast. Okay, so let's just go ahead and create a player. We'll put the player directly on the center of the screen. So x equals 320, y equals 240. And I'm also going to specify, a little dodgy to put it outside the class, but I'll just specify this here just to tune things up. So this is all well and good. What I want to do is I want to move the player with the keys. So I'll say, okay, let's get the set of all keys which are currently pressed. And the way we do that is we go into Pygame, into the key module, and then there's this get pressed function. Now this returns a sort of dictionary, and the keys of the dictionary are the Pygame key codes, which we can look up in a second. And the values of the dictionary are booleans. They'll be either true or false. So what I'll do is I'll make a movement list. Oh yeah, good point. I just realized this should be the same, but we should really be making this a list. Again, type hints are not enforced, and a list almost works the same as a tuple, but this is just a little more accurate. Now the reason I'm making this a list is I want to modify the elements of this. So if I have left, then I'll set the X movement component, but then if I have right, I should reset that so that they cancel each other out. Anyway, enough talking. So we'll go keys pressed, and I'll look in there and I'll say, okay, is the left key button down? Fair enough. And a lot of the time you'll see like an if-elif, but I just want to make if statements because I do want these keys to be able to cancel each other out. Okay, so we're testing left, right, and then up and down. And this is correct because, again, up is a negative direction, down is a positive direction in the Y. Okay, so we've got all of that. Now we'll go move according to the movement, and that should be fine. Okay. Alrighty, cool. So then in the draw loop, we'll in the draw routines, we'll go and draw the player. So we can just test this. Here we have it. We move. Let's give it a second. And yep. Just checking that the bounds are working. Okay, yeah, I'm happy with that. All right. So now we can go ahead and make the blocks. So again, a block is pretty similar to a player. Should I use inheritance? Probably, but I'm not going to. Okay, so how will a block work? Well, pretty similarly. I'm just going to make another variable to track whether it's active or not. Yeah, get rectangle should work the same way. We will not need to move the block. But when we go to draw the block, we need to select the color. So we can say, alrighty, make a variable called color. Okay, set that up. And I'm also going to make another function just to set the state of the block. Okay, cool. What was it? And there was one more. There was one more function for the block that I need to implement, and that is the collision test. So I'm going to make a function called overlaps with, take in another rect, and return. So luckily, I mean, we could implement this by hand with our own code. That would be fine. But there's another, what is it? Another function here called collide rect. And what that does is it takes another rectangle and checks whether those two rectangles collide with each other. Yeah. Okay, good. So I'm happy with that. The block class is done. And now we can create a whole bunch of them. So we'll make a list. Okay, so for the X, now we're going to use the random module. And we'll make the X coordinate, well, just anywhere on the screen. So anything between 0 and 640. I'm not too concerned about the blocks being a little bit off screen. That's fine. And for the Y, I just want to set this up so that the blocks are never covering the player. So I know if we go, it doesn't matter, anywhere between 300 and 480, they will always be on the bottom half of the screen. So here I'm looping through 16 times. Putting this underscore indicates that we don't care about the temporary variable for the loop. That is perfectly fine. So yeah, happy with that. Then what I want to do is I want to make a function to indicate whether a player can move. And the arguments are going to be the player object and the blocks object. Oops, that's not none, is it? It's a bool. Okay, so how are we going to use this? Well, what we can do is we've moved the player, and then we can say, okay, let's say if not. So check the player against that set of blocks. If the player actually couldn't move to that spot, then reverse everything. So say movement 0, reverse it, and then move the player again. So this is essentially moving the player back to the position they were before they got into the illegal state. Okay, so now we can have a look at the canMove function. Okay, so as you can see, the reason that, I mean, I could very clearly do an early exit here, but it's because I'm setting the status of the blocks in the same turn that I want to actually look through all of the blocks because, well, the player could be colliding with many blocks and the player could move and come away from a block that it was touching, and we want the block's status to reset in that case. Okay. So what are we doing? We've tested if we can move. we've gone ahead and drawn everything, but we also need to draw each of the blocks. So we'll loop through for block in. So we've got that now, we've got all these blocks, we can move, and now, yep, we can see that we can see which blocks we're touching. Yeah, it's very cool. Very cool. So this is an example of managing a group by hand. It's not that bad, but there is another way to do this, and that is with Python's Sprite Groups. So let's have a look at Sprite Groups. Okay, so I'm going to go from top to bottom again. Starting with the player. Now, for this player, I want to, I want it to be a sprite. So I want it to inherit from Pygame Sprite, the Sprite class. In its initializer, I'll go ahead and initialize the superclass. Now, the thing with sprites is we need, what am I thinking? We need to have two things, a rectangle and an image, a surface. The surface is the actual pixel data that represents the sprite, and the rectangle is geometric data about where the sprite is. So as you can see here, we have self-image already. That's fine. We also need to make a self-rect, and these need to be specific names because that's what the superclass is expecting. So we go Pygame rect. For the left, we'll go x minus 16. For the right, the top, I mean, we'll go y minus 16. For the width, 32, and same for the height. And that's it. That is our constructor for the player. Now, we no longer, well, we can actually simplify this quite a bit. We can just go return self-rect because that is already created here. Now for the move function, things get a little more complicated. We want to go self-rect x, and then we'll use self-rect x here as well, and then we want to actually shift things around because now the rectangle's x coordinate is the left coordinate. So we say, how far right can the leftmost coordinate be? Well, it can be the width of the screen. Sorry, the width of the screen minus its entire width. So think about that for a second. Think about the edge cases. And then the furthest left we can be is just on 0. That'll be just, yeah. Similarly, the furthest upwards that the top y coordinate can be is at 0. And the furthest downwards is the screen height with the full height of the sprite separating, if that makes sense. But then there's something else that I realized. We need not just self-width, but self-rectangle width. And same here, self-rectangle height. Okay, that is looking good. Now, I'm going to split this up into, I'm actually not going to have a draw function. And the reason for that is that if we declare a self-image and a self-rect, then the sprite group will know how to draw this sprite. The sprite knows how to draw itself already. So I'm actually going to change this to an update function because I will need that. And for the update function, all I'll do is fill myself. Update my color. Okay, so now I'll do the same thing with the block. Okay, fill that in. There we have it. That's the initializer. There we go, return self-rect. That's fine. Now we do not need this overlaps with function. That will be handled automatically, handled automatically by the sprite group. So that's fine. And then again, this draw function is going to be the update function. Okay, so we'll just pop over to the can move function. Everything else is looking good. And we'll take the player, that's fine. But then for the blocks, that's not going to be a list of block objects. That's going to be a sprite group. Okay. So we no longer need to grab the rectangle. And let's do this. Let's go Pygame Sprite collide. And the way this works is it takes a single sprite and a sprite group, and we also have to specify whether we want to destroy everything that collides. And it returns a list of sprites. So it returns a list of sprites in the group which collide with the player. So we'll say sprite is the player, group is the blocks, and do we want to kill the blocks which collide? No. Although we could do that if we wanted the player to barge through the group of blocks. Anyway, so this returns the list of sprites which collided with the player. So we'll save that to a variable. And then it's quite easy to say, can we move? Well, that is the condition of whether the length of the hit sprites is equal to 0, right? If there's nothing that hit the player can move. Okay, now what I want to do is I want to look through each of the members of that sprite group. So this sprites returns a list of sprites. That's just everything in the group. So we can say if, okay, so we'll go set active, and the variable we want to set there is whether the block that we see is also in the group of, in the list of things that hit. So we'll say block in hit sprites. Okay, there's two usages of the keyword in. One is for looping through a group, and the other is for testing if this block is a member of this other group. Okay, so just double checking there. Yep, I'm happy with that. Okay, so now we'll just head down to the main function and finish things off. So I'm going to have two groups, one for just everything in the game and one for the set of blocks. And that's okay. You can add a sprite to multiple groups. That's perfectly fine. It's a good idea, in fact. So take the visible sprites and add the player. Okay, and we'll start looking through, and I'm going to make a... Now the reason I'm going to put this in a variable is that I want to save it into multiple groups. Okay, so all of these 16 blocks that I make are in the game group and in the block group. The rest of this will be pretty similar. We'll go through, we'll check the keys, we'll move the player, maybe move the player backwards if we need to. Then what I'm going to do is I'm going to take the visible sprites and call the update function on them. Now, the update function will automatically run the update method of every member sprite. And see here we can add some keyword arguments if we want to pass in custom data for the update function. I'm not. I'm just going to leave it like that. Then down here, where we draw the player and draw the blocks, well, let's just draw the whole sprite group. And we need to take the surface that we want to draw to. So we'll pass in the screen surface. And there we have it. So the code has neatened up quite a bit. Right, of course, I forgot to set the inheritance. There we go. Okay, so just like before, we can move around and collide. And see, we're just using one method call to draw the whole group. So yeah, there we have it. That's Sprite Groups. It's a handy tool. Okay, let's have a look at static classes. In programming, a static class is a single globally available class. Well, it doesn't have to be globally available, but the point is it does not have to be instantiated. It exists for the whole lifetime of the program and can be easily referred to from any other point in the program. Now, a class holds two major things, though that is state and behavior. Okay, and a lot of static classes, their nature will fall somewhere on the spectrum of being mostly state or mostly behavior. A static class which is mostly behavior performs more or less like a library of functions. Now, of course, we could just make a library of functions, but we could also implement that with a global class. A class which stores mostly state is sort of like a database that we can refer to from any point in the program. Let's have a look at the example we've been working with so far, where the player is a box and moves around with the other boxes. So let's say we have our program and we have two major classes so far. We've got the player class and we've got the block class. Inside the program, we have our main loop, and our main loop holds a reference to a player class and a reference to a bunch of block classes. And it also has, so I shouldn't call this program, I should call this, let's say, main. Now, we also have some functions which interact with these. So, for instance, we have can move is the major one. Let's put that there. Now, main holds references to these objects, and it goes through, it does its thing, and then it has a point where it wants to check if we can move. So what it does is it takes those references, throws them into the function, and the function throws back a result. But things are starting to get a little, I don't know, starting to get a little weird. So here's how I want to refactor this. I'm going to make another class, which I'll call, I don't know, game logic. And game logic holds references to a bunch of blocks, a bunch of players, and the can move function will put that into the game logic. So now, if we tell the game logic to move the player, then the game logic has its own routine in here, which it doesn't have to pass things around too much because these are the state and this can move is the behavior. And there's a whole lot of other functions as well. I just wanted to focus on this for my example. So we can say, okay, well, what messages can the main program send to the game logic? Well, the big ones I'm going to set are, it can tell the game logic to reset itself. It can tell the game logic to update, draw, and some other things. But the point is, this makes the main program a lot cleaner, because if you're working on the main program, you just see the messages that you're sending to the, you just see the high level messages that you're sending. And then game logic handles the details of how do we update things, how do we reset our state, and all of that. And this is separation of concerns. So yeah, that is the idea. Let's jump in and see it in execution. Okay, so here we are at the start point of the project. I'm not going to go through all of this, but I will talk through it. So what I've done is I've made two extra files, config, as in configuration, and classes. With configuration, we import Pygame. This is the really big important one. We can import a module from multiple places, and it does not redefine it. But we can only import Pygame once, which is why we have it here in this config file. And as well as that, we've defined all of the named constants in the config file, just a single place where we have access to them. Then in the classes file, I have got my player and block classes, just as before, with no modifications. So then we can see here, if I want to specify, for instance, that this player is of the player class type, I need to access it through the module classes. Yeah, just the same way as I'm accessing group from Sprite from Pygame. Okay, otherwise everything's pretty much the same. I've also made a handle keys function, and yeah, pretty much it's just I just took a bit of code out of the main loop because the main loop was getting a bit cluttered. But yeah, okay, that's fine. Then down below, if I want to make a player, for instance, I've just imported classes, so I create an instance of player from the classes module. But yeah, nothing too unusual here. We can just run this, and it does what it should be doing. Okay, that's fine. So let's modify this now so that we're using a static class. Now I'll go to the classes file and I'll go ahead and make one of these. So I'll make a class, which I'm going to call game logic. Keep that blank for now. And I'll make a variable called game context, and that stores an instance of game logic. So this is created once when the module is imported, and then it can be referred to from anything which imports it. So if I go to main, we've got all of this, clock and all of that. Let's go game context equals. Okay, so I'm just taking a copy of that variable just so that I'm not repeatedly accessing into the other module, just for efficiency. Why not? But then let's start working with this. So I'm going to take these blocks and visible sprites, and I'm going to say, okay, those are owned by the game contexts. And I'm going to also grab, well, basically I'm just going to grab all of this stuff here. Now with the player, I'm also going to I'm going to store that in a variable. I'm going to do that for all of these. These are all going to be instance variables. So the game logic owns and knows about all of these things. It owns the blocks group, the visible sprites, and all of that. Okay, so just a whole bunch of retyping, that's fine. Okay, so let's go back here. Alrighty, so I am going to send the handle keys function. Yeah, why not? I'm going to send the handle keys function and the can move function over to the game context. It can handle those. So I'm just changing this so that instead of taking those groups, it refers to its own groups. But otherwise, it's the same stuff. So can move, I'm happy with that. Handle player. Again, we do not need to take these as arguments because they are stored within the class. They are the class variables. Okay, so we get the keys. And here we're just going self player move and self can move. Okay, that's fine. So now let's go tell the game context to handle the keys. That's fine. And now we've got two more parts. We've got visible, we've got the update and the draw, but I'm actually going to just grab these and make them into functions. We are going to need a surface. Right, so tell the game context to update itself, and then we'll tell the game context to draw itself. So we can test this, give it a shot. Okay, that's good. Now there's one more thing I want to do, and that is I'm going to break the initializer into separate stages. So I'm going to make a function to reset the state of the game. And when I reset the state of the game, what do I want to do? Well, I'm actually going to leave the player object alone and just delete all of the blocks. The reason for this is we may be at a stage where we're happy with where the player is. We want to keep the player as a persistent object, but change other things in the game. So I'll just go for, so I'll loop through for block in this. Doesn't seem to recognize. Oh well, that's probably fine. Oh, spites. Hey, it happens to the best of us. So what I want to do is I want to get rid of the block. I want to remove it from everything. Okay, and what I'm going to do is kill the sprite. Now it says here, this removes the sprite from all groups. But it also says that this won't change anything about the sprite. If we hold a reference to that block, then we can keep working with that block. However, because we are using this as a temporary variable in the loop, that does not hold a reference to the block, and the garbage collector will remove it. So this does actually get rid of everything. Then I'm going to make another function called load random state. And that's going to be this one here. Okay, so see, the creation is split into two stages. First of all, we remove any existing blocks, and then we load in a whole bunch of random blocks. Okay, so what we can do now is we can go self reset state, and then self load random state. I know we technically don't need to say reset state because currently no blocks have been created, but why not? Now I'm also going to grab this code and just test it. So I'm going to go to the main, and I'm also going to test. So I want to say, okay, when I hit space, then reset everything. So I'll go if event type is key down, and the key is the spacebar, then we'll do this. Okay, so have a look at this. Look at how nice and clean the main function is. The only interactions we can see with the game context are high-level, well-described functions. There's okay, there's a for loop here. But there's no nitty-gritty details. The implementation is in here. Okay, so the person designing the game needs to worry about the implementation, but the person designing the program structure does not. And if you're like me, you're the person doing both. So this is really clean. Let's just load this and check that it's working. Yep, that looks good. And now we can hit space, there, and we're loading in a different one each time. Of course, it's randomly generating. So as an extension exercise, the first video in this series was looking at loading text files. Try to load, try to load it from, load the map from a different text file. If you want to extend yourself, try saving everything to a file and then loading another file. So in the game logic, we have this reset state, load random state. Try making a load from file. Takes a file name, loads from the file. Try that. And maybe key it up so that when you hit like 1, 2, 3, it'll load a bunch of different files. It's a good exercise. Anyway, hopefully this was enjoyable. Hopefully you learnt some stuff, and I'll see you again in the next one. Bye. Now on to another really important design pattern. And this is the, I would call it the gold standard design pattern of game design, game dev, but that's just me. I'm a little bit biased. And that is model view control. Okay, so let's give an example. Let's say we are playing a game. Let's say we're playing a three-dimensional game. We'll start with the view. And the view is literally the data which gets displayed on the screen, whatever it is. Now, that view does not store a lot of information. It stores some information. It stores textures and things like the pixel data that it needs to draw things, but it reacts to a message from the control. So the control tells the view to draw, and it also passes in some sets of data that it needs. So for example, it's saying, okay, draw, and the square position is this XY coordinate, and these other shapes are these other XY coordinates. Now, The model actually handles the underlying data. For instance, x equals this, y equals this. It's like a database. It's a static class which is mostly, well, it's a combination of behavior and state, but it holds all the data for the game as well as implementing the logic for updating the data. Now, a message that the control could send is something like move player, for instance. So the control class tells the model to move the player, and then the model moves the player, updates it, works with its behavior, implements its behavior, and all of that. And the model can also pass data from the model can be queried by control. For instance, when we want to draw, the control class will query data from the model and then pass that along to the view. Now, in between, the control is basically the keyboard and the mouse, whatever other input device you want. So any key presses are handled by the control class, and then it sends appropriate messages to the model class. Now, in some cases, if we're working with a graphical user interface or just any sort of generic programming, the view classes could be clickable, they could be interactable. So they might be sending messages back to the control. However, we'll look at this in a future video, but it's more common for the control to register a callback function with these. And the callback function could be defined anywhere. It's often defined inside the control. So for instance, we make a button and we tell the button, hey, when you get clicked, this is the function that we want to get called. So when that button gets clicked, that is called. It's often within the control class. But yeah, again, this is moving towards cleaner code and separation of concerns. So let's have a look at refactoring our existing program to work within the model view control design pattern. Okay, so let's get started refactoring this to follow a model view controller pattern. First thing we're going to do is just go to this classes file. By the way, this is the same stage that our code base was at from the last video. We'll just rename this, and I'm going to rename it to model, because this is going to have all of the model classes. One thing I'm going to do is see that we have, for all these sprites, we have an image. And this is fine if we just have the player. We only expect there to be one player. But then later on, we have block, and every single block has its own image. But really, when these things get drawn, we'll be drawing the one image in a whole bunch of places. So what I'm going to do is I'm going to get rid of the image. And that's actually fine. The reason that's fine is in order to do collision checks, we just need a rect. We don't need an image. So we can get rid of this update function, but I am just going to make a get rect function. Yeah, I'm going to make a get rect function because I'll be using that later on, because we will need to know where to draw these things. So all of these will have a get rect function. Okay, so the player function, the player, that is fine. The block class, again, we're not going to use an image in this class. I'm also not going to, I'm going to handle this in a different way. So I'm not going to have an active property, and I'm also not going to have an update function. Okay, so we're just simplifying it. Now, for the game logic, we're going to have blocks and visible sprites. Okay, fair enough. Now let's go I'm going to make a few other groups. I'm going to make a group for inactive blocks. Ooh. And the active blocks. And the idea here is instead of keeping track of the status, I'll just be adding them to different groups. And then I'll be sending those groups to the renderer, and the renderer will say, hey, we have this group. Everything in this group is an inactive block, so we know exactly how to render that. The rest of this I'm happy with. Load random state, yeah, that's fine. We'll just add it to blocks and visible blocks. Okay, now in here, in this can move, what I'm going to do is I'm going to clear both of the block groups. So I'll go self, inactive blocks. Now this is a little deceptive. It's a point where it's good to read the documentation. So if we hover over here, it says this clears the area under every drawn sprite in the group. That's actually not what we want to do. We want to remove all the members of that group and basically set it back to an empty set. So it turns out there's another function here. And by the way, the only way I know this is just hit a dot in IntelliSense and scroll through. There's this function called empty, and that removes all sprites from the group. So that's what we want to do. So I'm just going to make sure that both of these groups start off empty, and then as I progress, I'm going to throw each block into one of these groups. So, okay, go. So we look through all the blocks, and then we say, if that block is in the set of blocks which are being hit, then add it to the active blocks. Otherwise, add it to the inactive blocks. Okay, so this ensures that every time we do a move test, the active and inactive groups are updated to have the correct block sprites. Say that a few times fast. Okay, so handle keys. We'll leave that for now. What I'm going to do is I'm just going to make the model and view, get that working, then I'll make the controller. When I make the controller, I'm going to jump in here, grab this code, and handle that elsewhere. Okay, so I'm going to make a few functions just to return some basic data. I'm going to return a list of those block instances, and we'll use the sprites function, which returns a list of all the members of that group. So I'm going to just get rid of the update thing and just have handle keys. That is fine. Going to get rid of the draw function. The model class should not be doing any drawing. And there we have it. I'm happy with that for now. We can pop over and have a look at the view class. So we'll just add a new file, call that view.py. Okay. So, of course, we'll import everything. And I'm also going to import the model class. Now, at this point, it's really important to remember that we don't want circular import. So we want to make sure that the model module is not importing the view module. Otherwise, they'll keep going around in loops. That's not good. But I am going to import the model module because the view, the renderer, needs to know about the fields for the player and block class, because it needs to know how to work with those. Okay, now I'm going to import a bunch of these things, specifically the colors, because of course the only module which needs to know about the colors is the view module. So I'll go through and everything that says color, I'll grab that. Okay, I'm going to define a few other constants, and those are sprite types. Perhaps not strictly necessary, but this is how I'm going to implement this. What do we have here? Main, what's it complaining? Oh, that's fine. We'll get to that in a second. Okay, where was I? So, I'm going to make a class called renderer. Okay, so the renderer basically works with the screen. So the first thing I'm going to do is, if we look up here, we have this screen surface. I'm going to perform that initialization inside the renderer class. Now I'm also going to make this into a singleton, make it into a static class by instantiating it once in the module. And then if we head over here, we'll just, what is it, import view, and grab that. So at this point where we import it, that is where the everything is initialized. And yeah, that should work. Okay. So the next thing I want to do is I want to create the images. I'm going to use a dictionary for this. So I'm going to say, okay, the player image, I mean, these are all going to be the same, but we will need to name them because later on we're going to fill them. Okay, so I'll have surface. There we go. Okay. Good. So we can look these up, and each of these has a surface. Now, of course, they're all going to look the same at the moment. So what we'll need to do is fill them in. So we go self images, get the player, and fill it with the player color. Okay, get the inactive block, fill it with the block color corresponding to inactive status, and then fill the other one with the block color corresponding to active status. This is basically, we're just looking up the dictionaries which we defined up above. Okay, so that is all good. Let's leave that for now. Now we'll go to this, make the draw function. Now the draw function is going to need to take all of the information that the renderer will need to draw the screen, just as we saw it before. So in other words, we will need to take a player instance. It's an instance of the player class. We'll need to get the group of active blocks, which will be a list of block instances, and we'll also need the inactive blocks. Okay, so how will this go? Well, it'll basically be the same rendering script as we saw before. So we'll go back over. That's one thing that we'll do. Okay. We need to save this. There we go. Okay. And the other thing is, let me just change this. I'll make this the renderer context, and we do not need to tell it which surface to draw to. It already knows that. Okay. So if we run this, of course, we're just going to see the sky. If we see anything, yeah, it might be complaining. Yeah, it needs, okay, fair enough. So we need to draw, and we'll say, okay, for the player instance, we'll go tell the game context, hey, I want to get your player, and so on, and so on. Okay, cool. So see, we send various messages telling the game context to update its state, and then we query the state of the game context to get the renderable objects, and yeah, tell the renderer to draw them. So if we run this, yeah, now we see the sky because we need to render the player and the blocks. But that's okay, that's no problem. Okay, let's do the inactive blocks first. So we'll say for block in the inactive blocks, blit that on. Now the source that we're going to blit is, if we look at our images, we'll grab the inactive block image, and the destination where we're blitting it is, if we look at block, get the rectangle, that will tell us exactly where we need to blit that. So give that a go. Oh, what have we missed? I guess maybe we should be doing that. Let me just double check the model. Oh, I just realized something. I just realized this is actually a very subtle error, maybe. So if we run this right now, of course we can't see anything. Then we hit a key. Oh, okay. We still can't see anything. Okay. There we go. This is an even more subtle error because it's an actual error. For get inactive blocks, we should be returning inactive, not active. Okay, give that a go. And yeah, there we can see the inactive blocks. Okay, great. How many times am I going to say active, inactive? Okay, so let's do this again. But just with the active blocks. That's fine. And then let's do it again with the player. Yep, so give that a go. That is working. I'm happy with that. We can close that. And I want to do a little bit more with this view. I want to put some text on the screen. So let's say we want a little window giving the players X and Y coordinates. So in order to do this, I'm going to need to import another module. If we just go to config, there is a module called Pygame free type, and that is basically a font library. I'm going to import that. I'm just going to call it font library. Okay, and yes, we can go back to the view, and I'm going to define a few more constants. I'm going to define the text size and the text color as well. Okay, so then we'll go back to the initializer. Now in the initializer, we need to initialize that font library. It's a separate module to the core Pygame module. So what we do is just go font lib init, and then I'm going to make a font object. So I'll say self. Okay, so self screen font, we go font lib, and there's many ways to make fonts. I'm going to make a system font. So for the argument, take the name, go Arial. We can actually provide any sort of iterable, like a list of names, if you want to check off a bunch of names and make the first one that we see. But yeah, we have size, and for size I'm going to go, screen text size. Okay, that's looking good. And then I'll just go down to the draw function. I'm going to make a change here. So we have the player rectangle, but I'm actually going to save that to a temporary variable. Use that there. And then I'll go ahead and render the font. So I'll go self. Now, there's a bunch of different render options. We have render to and render. Now, render to will render directly to a surface. Render will return a new surface. I'm just going to go render to for this one. The surface we're going to render to is the screen surface, of course. The destination, top left coordinate of this. I guess it really doesn't matter too much. Let's just go 32 across, 32 down from the top. Okay, the text. So we want to get the player X. So we'll use an F string. We'll go, and then we'll get that player rect center X. That's fine. And then the color, foreground color, we'll set that to the screen text color. Then we'll do that whole thing again for the Y coordinate. So we'll drag the text down a little bit, maybe another 32 pixels down. We'll go player Y equals center Y, but nothing else has to change. So we can run, I'll just put that back there. Okay, so that's how we do it. We can run this. And yeah, now we have the coordinates. Okay, good. So how do we make this into how do we add a controller class? It's actually not too bad. So we'll just go make a new file. Okay, so here's how we're going to define our app. We'll go ahead and we'll basically get all the imports from main. And then we'll go here and say port controller. Okay, we're also going to grab the contexts. Alrighty, so there are basically two stages right now to this. There's an initializer, and then a run function. And they are both going to do what they're doing right now in the main. So I can look at this and say, you know, of this code, which bits of code are involved in initializing? Pretty much the first two lines. Okay. Should probably save that into the class. Okay. So we initialize Pygame and we make a clock. Okay. Now, here we can replace that and say, well, all we're doing is basically creating an app. And then we can look down here and say, well, this is really the main loop. So we can grab that, put that into the run function. Pretty happy with that. And then we can replace this and say, run the app. So now the main function is incredibly clean and nice. And the controller is still nice and readable. And yeah, there we have it. Nice, clean app. Cool. So yeah, this is just an example of adapting our program to the model view controller pattern. Hi, this is just a little addendum to that. I completely forgot about the handle keys function. So what I have up here right now is the finished version of this code base, and I just want to talk through how this works. What we would do is if we go to model and then go down to the, where is it? Yeah, go down to the main, the game logic class. See, there's no handle keys function. There's no handle keys function. What we do is we take that code, we put it into the controller class. There it has this handle keys function where it detects its keys, and then it passes a message to the game context and says, hey, I want you to move the player by this amount. So the way the player works, the way the move player works is we go to the model. The move player is everything else that was originally in handle keys. So we take that movement, move the player, we check if we could actually move, and if not, then we move back to where we were before. So yeah, hopefully that makes sense. Sorry, I skipped that bit, but there it is now, and it is in the finished code. And yeah, we can move around, and it works the same as before. We are just separating things so that the input handling code, the key and mouse handling code, is handled by the controller. And then all the model sees is we want to update our state by moving the player object. All right, so in the previous video, we looked at the model view controller design pattern, and in this video, I'm going to focus in a little bit more on the view pattern. Now, at the moment, we've just got the game state and a little bit of status in the text, just up on the side. What I want to do is I want to look at making subsurfaces. That is, we have a render target and we draw some information to it, and then we draw that render target, that surface, onto the main screen. This lets us make compositions of surfaces, and it's pretty good. So all of this work is going to be in the view class. We're going to work with what we have at the moment. Just looking through here, I'm pretty happy with this. I'm just going to define a few other things. I'm going to define a background highlight color. And I'm also going to define a text panel color, which will just be black. Also, if you notice any background sound coming in, I'm dealing with an Australian summer yet. Actually, we're not even into summer, and it's already feeling like it, so I just had to have a window open. It's a hot day. Pretty good day for coding though. Okay, so we've got those constants defined. Now, if we go into the renderer class, see we're making a screen surface. I'm also going to make, let's just go with a text banner for now. So I'll make a banner surface. And for the size, we will go 128 pixels wide, 64 pixels high. So I'm going to render the text with the player's position onto this banner surface. Then I'm going to render the banner surface onto the screen surface. But if you look at this, 128 pixels isn't actually that much, especially for the text that I'm putting out. So I'm going to make this text scroll. So I'll make a variable called screen scroll x or something, and we'll just set that to 128. Oops, 128. So the text is going to start 128 pixels back and then scroll across the screen. So go to the draw function, and I'll just go down below the draw function, and I'll make a another step. This will be a sub-step of drawing. So the point is, we think, okay, the goal is we want to render a bit of text which indicates the player's position. So we think, okay, which information do we need in order to do that? We need the player's rectangle. So what I'm doing here is I'm just updating the X coordinate on which to draw everything. And then if that gets a certain, a certain width, within a certain threshold, then we reset it to the right side again. So this text will scroll right to left and then back to right. Okay. So we'll fill that banner surface with the text panel color, and then we'll need to render. Now, see, before we were using render 2. I can actually grab that, put it here. The issue with render 2 is I found that if we go outside the bounds of the surface, then it messes up. So instead of render 2, I'm going to use render, and I'm going to save that to a temporary surface, and then I'm going to blit that onto the banner surface. So we'll go blit. Okay, so the source, of course, is a temporary surface, and the destination, the place we're putting it, will be, let's just go, the coordinate for the top left. So we'll go take the screen scroll X as the X coordinate and just blit it at the top of the banner surface. Okay. So we'll switch this to the render function. Now the render function, see here, we take the text and the foreground color, and those are really the only things we need to specify. But this is really important. It says here this returns a tuple of a surface and a rectangle. So let's get rid of everything apart from this. And then, because this is returning a tuple, I want to access the first element of that. That will give me the surface. I don't really care about the rectangle because I'm making my own rectangle here when I blit it to the screen, to the banner surface. So then I'll do the same thing over here. And let's just bring the text down by 8 pixels. Okay, so go player Y, grab the center Y, all of that is fine, and then we'll bring it down another 32 pixels from that, so down to a height of 40 pixels. And that's it. That is rendering the text panel. So we can think about it as what this function does is updates the image content of our banner surface. So we can close this down and we can say, okay, we'll do all of our stuff and then render the text panel. And in order to do that, pass in the player rect that we got before, and then blit that on, oh, no, not that. I don't know what that is in its subclass. We'll blit that onto the screen surface. Okay, so we'll send in, what do we do? Let's just send in the banner surface, and for the coordinate, we'll go just the same as before, 32 pixels across, 32 pixels down. Okay, So let's give this a shot. Check that this is working. Yep, good, okay. Player X, player Y. And if we move around, we can see that this text is updating. Look, it's not the most stylish, but the point is it's a subsurface. It's a composition of surfaces. Okay, so the next thing I want to do is I'm going to make another surface which is like a zoomed in view of what the player is seeing, if that makes sense. I'm going to call this a zoomed in surface. So we'll go ahead, we'll make a zoomed in surface. Okay, happy with that. We can go down to below the, actually, I'm going to make a copy of this because the zoomed in surface will really almost be using the same information that the regular view is using. So I'll call this render zoomed in view. And we're going to need to know about all of these other things as well. Okay, that's fine. So now we just go through the motions. So we fill the zoomed in surface, and then here's what I want to do. What I want to do is for all the blocks, I want to subtract away the player's position so that they are centered around the player. So in order to do that, I'll need to get the player's rectangle. And I'm also going to have a transformed rectangle, which I'll just put placeholder data. So 0, 0, 0, 0. That's fine. This is I'm really just registering this out of convenience to know that this is meant to be a rectangle variable and all of that. Okay, so what I'll do for each block is I'll get the block's current rectangle and then I'll move that. Now, the way this works is it takes in oh, what's up with that? It takes in an X and Y coordinate, moves the rectangle and returns, well, it really returns a copy of this which has been moved by this amount. So in order to subtract the player's position, I need to subtract the player, rectangle center X and center Y. But then we will run into trouble because let's take the player for instance. The player should be the center of this surface because we subtract our own position, we center it off. However, when we subtract our own position from our own position, that goes to 0. And 0 is not the center of a rectangle or a center of a surface. It is the, let's say that. It's the top left corner. So instead, I want to subtract the player's position and then add on half of the width and half of the height. If we're going 64 by 64, then half of that is 32. So yeah, 32. So that sets it so that the coordinate 0, 0 now becomes 32, 32, which is the center of the surface, which is what we would expect. Okay, so then what I want to do is I want to blit this to the zoomed in surface, and for the destination it'll be the transformed rectangle, and that's it. So we'll go ahead and do this for the rest of them. Just double checking. Yeah. And then the same here, but we can just use the temporary variable which we got before. Okay, that's looking good. Of course, we don't need to do any of this stuff. And also above, I'm going to use that background highlight color just to really show where the surface is. So there we have it. That is just setting the zoomed in view. We can go up here. And what are we doing? We're rendering the text panel. Let's go self render the zoomed in view, pass in the same data. And then we want to blit this. So we go self Now what I'm doing here is I'm trying to put it on the right hand side, so I take the width, I subtract 64 because it needs to fit on the screen, and then I subtract another 32 just to make it look nice, give it a bit of padding. So we can run this right now, and oh, that's interesting. Let me check that again. Doesn't look like we're oh, okay. How did I miss that? Destination should be the transformed rectangle, not the player rectangle. Look, if you take anything from these little blunders that I'm making, it's that game development, it's problem solving. It's always a little bit different. It's not easy. You know what is easy is making mistakes. Okay, so yeah, we've got this zoomed in view. Now, another thing we can do is what if we want to make it bigger? Apply some post-processing. Well, remember, this rendering, the goal is just to fill an image. Okay, and we did a video previously where we scaled things, so let's go ahead and scale this. So we'll just go, before we blit this, I'll make a transformed surface. I'll go Pygame, transform. I want to go scale, and there's a scale 2x function, so let's do that. The surface we're going to transform is the zoomed in surface. There we have it. Okay, so if I double that, that's 128. 128 minus 30 plus 32 is 160. Okay, fair enough. So now see we have the same surface, but the surface has been scaled up. Don't know if you can tell. No, the scaling's pretty good. It doesn't look pixelated or anything, but yeah. Okay, cool. So this has just been an example of working with subsurfaces. All right, so this is one of the, probably the code heaviest segment of this course. In the previous video, we were looking at subsurfaces. Wouldn't it be great if we had a system for organizing subsurfaces? Well, a lot of modern GUIs, graphical user interfaces, have different sorts of layouts where we can arrange widgets. And that's what I'm going to look at in this section. Specifically, I'm going to look at two sorts of layouts, horizontal stack and a vertical stack. And I'll make some widgets to go in there as well. So I guess we'll just take this one step at a time. Let's start with a vertical stack. Now, we have this vertical stack, and I'm actually going to inherit from the Pygame Sprite class. And the reason for that is that a stack will have it'll be like a sprite. It'll have a rectangle and a surface representing the area of the screen that it's responsible for, but it'll also have a sprite group which represents the children, the widgets which are packed into that stack. And for that reason, I want to make the stacks themselves a sprite so that we can have stacks within stacks, if that makes sense. Okay, so these are the arguments we will take to create a stack, a vertical stack. Because we inherit from Sprite, of course, we'll run the superclass constructor initializer. Then let's set up a rectangle for the stack and an image. Okay, let's go ahead and fill the whole thing. Now there's two sort of new bits here. Because the stack, if it's vertical, it's going to go top to bottom. I want to keep a running total of the lowest point that we've seen so far, the lowest y, or the largest y coordinate, I guess, corresponding to the lowest point on the screen. And I also want to keep track of a sprite group, which is everything which is owned by the stack, which has been packed to the stack. Okay, so we'll have, not draw, we won't do that yet. We'll want to add something to the stack. Okay, so we'll have a sprite that we are adding to the stack as well as any padding that we want to add. Okay, so no worries. First of all, we'll add this to our contents. And then we'll increment the lowest point on the screen that we've seen so far by the y offset, if there is any. Then what we can do is we can go to the widget, get its rectangle, and then move in place. So before we used the move function and that returned a new copy of the rectangle which has been moved. Move in place will simply move the existing rectangle, and that's it. So what do we want to move it by in the x? We want to move it by the x offset, and then in the y we want to move it by the y bottom parameter. And that's it. That's all we need to do. Then we'll have the draw function, and all that's going to do is draw all of the widgets. So we're going to draw those, and we're going to draw them to our image. Okay. So to go along with this, I'm going to make a vertical stack. I'm going to have a top bar, which is all black, and that's going to have some status information. And then I'm going to have a bottom rectangle with the rest of the screen. So what do I need to do? I'm just going to head to the config, and I'm going to give myself a little more space on the top. I think I worked this out before. It was about 192 pixels I'm going to use as the height of the status bar. Okay, fair enough. Then I'm going to make a class. Oh, def class. Okay, so here's what we've got. This map view is going to be responsible for rendering the map, the player, and the blocks. It's going to take in a rectangle, but that rectangle is not going to have coordinates, really. It's going to be centered at 0, 0, or top left 0, 0. It's just really storing the width and the height of the whole basic view. We'll have the background color, of course, is going to be the sky color. And then the images, because this images library is going to be used by several views. We're going to have the map view and then the mini map view. But anyway, get into it. Okay, cool. So the idea about making this custom class is this custom class should know the rules to do what it needs to do. We can go down to the renderer where we're working with this and basically take all of this, and this is what the map view is going to be doing. So we'll just pretty much refactor all of this, just splitting to our image. Okay, so I'm going to close this down. I'm going to go down to the, we can close all of this. I'm going to go down to the renderer class and all this stuff. Okay, so I'm going to break this in. I'm just looking here. This is starting to annoy me. I'm going to break this into a few functions. So I'm going to make a create assets function and a create layouts function. Okay, so layouts. At the moment, we've just got one layout, which is the vertical stack. Okay, so X and Y are 0 because we're centering it, top lefting it at the top left of the screen. Width is, just go screen size. Height is screen size as well. Background color, doesn't really matter, does it? Actually, that's black anyway, so we'll go with that. Okay. Now we can just go. Okay, so create a map view. The rectangle, just go make a rectangle. Coordinates don't matter. For the width, it's screen size 0. For the height, take 192 pixels away. And that's it. Okay, background color is going to be, where was I? Just the, whoops. Come on. Yeah, there we go. Just the background color. And then the images will be the images dictionary, which was made in create assets. Okay, so then we add that. So the widget we're adding is the map view. The X offset, no X offset. The Y offset, we want it to be 192 pixels down on the grid. Okay. So now over here, what we'll do is I'm just gonna clear all this off for now. There we go. Okay, cool. That's probably fine. Take it with a bit of faith, grain of faith, as they say. So again, this map view render is simply updating the surface, the image, which the map view holds, and then the draw function is taking that image which has been rendered and splitting it into the appropriate rectangle, appropriate area on the layouts image. And then this is taking the layouts image and drawing it onto the screen. So we can just give this a shot, see what this is doing. No worries. We've got that black area, and because of the offset, our screen, our game area, is down below. Okay, so the next thing I want to do is I want to create a horizontal stack and put a horizontal stack into this area here and fill it with some other widgets. Fill it with a status view and a mini-map view. Okay, so that's why I said this is the more code-heavy section. So we'll just take this vertical stack and duplicate it. And again, this is one of the cases where we probably should use inheritance. I don't like inheritance, that's just a me thing. So I'm just going to do it this way. Ignoring the fact that I am inheriting anyway. But, we don't talk about that. Okay, so the initializer, only thing we need to change really is the state which updates is the rightmost section of the stack. As we add things, it goes along from left to right. Okay, so when we add, we update x right, and we'll just move it in place. Yeah, so it moves to the rightmost point that the stack has currently, and just applying any offset which has been set here. But otherwise, none of that has to change. So we've got the map view. The next view class I want to make is a status view, and that will make the text basically. Okay, so again, we can take most of the constructor and reuse it. And the only thing we're changing is the font. And I'm also going to, make that scroll X variable. Then we'll have the render function, but if we look down below, the render text panel is basically what we need. So let's just grab that. And then, just like before, it's a lot of fun. We want to fill this with and that self image that we're filling there. Yeah, it's fine. Screen text color, that's okay. Okay. Double checking, that seems all right. All right, so see, once you get past this initial difficulty curve, making more widgets and putting them into layouts gets a little bit nicer. We can go down to create assets. Okay, so we do need a screen surface. We don't need a banner surface anymore. And let's get rid of this as well. Don't need that. We will, yeah, I will save this as an instance variable. Okay, so what do I want? I'll make a status bar, and that's a horizontal stack. Again, the X and Y don't matter at all. The width will be based on screen size. The height will be 192. The background color, yeah, it's black. Okay. Okay, we'll add the status bar at an X offset of 0, a Y offset of 0. Yes. And because that has a height of 192, that will now be filling the space. Okay, and then we'll go ahead and create the component which will go into the status bar. So that is okay, cool. So we have created the status view, then we need to add that. Okay, cool. So then we'll go down here and I'm just gonna, we can get rid of this stuff. You know what, why not? Let's go top to bottom. So we'll go okay, so we rendered that and then draw the status bar. And then, yeah, the rest of that should be fine. Yep, so that gets drawn into the status bar, and the status bar is part of the layout. Yeah, let's give that a go. Uh-oh. Not sure how I missed that. Actually, I do know how I missed that, because I missed things. That's the life of a programmer. But, of course, what we should be doing is increasing the bottom point by the rectangle's height. And that was in the vertical stack, and then similarly in the horizontal stack, we should be increasing the rightmost by the width of what we just threw in there. Okay, let's give that a go. And there we have it. Have a nice layout. The rendering code is clean. Everything is good. Okay, cool. So, final part now is I want to add another widget to my horizontal stack and get a mini map over here on the side. So, it's actually not too bad. We'll just go up here, grab the map view, and duplicate it. Okay, now remember that with the mini-map, I render a little version of it and then I blow it up. So I'm actually going to call this the original image. And then for the render function, I'll go down, grab the render function that we had down here. And then I'll put this in place up here. Again, this is the original image that we're filling. So then we do all of that. And then remember, in order for a sprite to draw, we need to set a self image. So we'll go into the Pygame transform module and we'll scale twice our original image. And then that's it. That should be the mini map. Okay, so then we'll go to the create layouts, and here where I make the map view, copy that. So make the mini map view that will have a width of 64 and 64. That doesn't matter. I'm actually not even using that argument, but that's fine. And then we'll go ahead and add that to the status bar. So we'll go status bar, add X offset of 256 because we want to set it a little bit apart from the text, Y offset of 32. But yeah, yep, that's looking good. Then when we go down to draw, what do we have? We render the status view, and then we'll render the minimap view. Then we'll draw the status bar because all widgets of the status bar have been rendered. Then we'll render the map view, draw that, and then blit onto the screen. So now we're coordinating a bunch of different activities and the code is looking good. Now let's double check, see if I made any blunders. Okay, what do we have? Ah, that's easy enough. That should be render. Okay, cool. So yes, now we have our layouts working as, I mean, really, okay, for a simple example like this, we might not need this much machinery, but if you want to make a more complicated layout, if you want to make layouts inside of layouts, like we have a horizontal stack inside a vertical stack, then a system like this might be a good idea. At the very least, if you're doing graphical user interface programming, you will be working with layout systems like this anyway, so it's good to understand. Okay, so that is it. I know it was a bit of a marathon, but we got there in the end. See you in the next one. Okay, a nice quick one. Now, I want to look at function references. Function pointers, something like that. So in Python, we can take functions and store them in variables. So here's a function, say hello. Okay, fair enough. There's that function. Now, what I can do is if I print the name of the function, then it tells me that is a function called say hello at this hexadecimal location. That's some sort of local program space address where the function is stored. So because that function is stored somewhere, we can store a reference to it. So let me say a variable called greet is going to be the location of the function. And we can verify this by printing greet. And yep, greet is pointing to the function called say hello at that location. Okay. We can also call the underlying function just with these brackets here. So the name of the function without the brackets is the reference, where it is, and the name of the function with the brackets will actually execute that function. So as you can see, it prints hello. And we can make this as general as we want to do, as we want it to be. So let's make another function. Say hello under duress. I'm court ordered to say hello. Okay, cool. So then just as easily, we can set this variable to that other function and call it. And yeah, so the first time it's pointing to this say hello function, and then the second time it gets called, it's pointing to that other function, say hello under duress. So the point is we can store references to functions in variables. We can call the functions. Now, clearly it doesn't matter. We can have any sort of function at all. So let's make one that is say hello to. Okay, fair enough. Then we can set our greeting function. And then we can greet Python. So again, this is super important. The name of the function without the brackets, and then adding the brackets is calling the function. We put in whichever arguments we need to. So there we have it. Hello Python. Very cool. Okay, here's another one. What if we want to pre-bake the argument here? So let's say I want to save this and say, hey, when I call greet, I want to execute this function here, but I don't want to execute it right now. So the way we can do that is with something called a lambda. So we'll just go, I'm just putting this input statement in here just to show that the function is not immediately executing. So what we're doing is we are pre-baking this function call into this lambda, this anonymous function, and saving that in here. So when we run that, it should run this as well. Okay, so as we can see, it's waiting. This say hello to has not executed yet. If we go to the console and hit enter, then the input statement clears. We go on to the next line, which calls that. And yeah, so we have pre-baked the function call. And the other thing we can do, besides pre-baking function calls, is we can have functions which return functions. Now for this, I'm going to add a few more modules. Now, random, because I'm going to make a function that randomly chooses one of these top two functions, and then callable for the type hint. So what I'm going to do is I'm going to make one. Okay, so the return type of this is some sort of callable function which takes no arguments and returns nothing. So if, for instance, we took a string and an integer, then they would be declared over there. If we returned a float, that would be declared as the second argument of this outer list. But as it is, we expect this routine to take no input and return nothing. Okay, so there's a 2/3 chance it's just a regular say hello. We'll return a choice out of those. Okay, so now we set, we run this routine, which will return a function, and that will get, function reference will get saved into greet. And then when we call greet, it just calls whatever function was returned, whatever the choice was here. Okay, so just give this a second, go okay. All right, so it says here, it was they were saying hello under duress. Whoops. Oh well, that's fine. So this is just a brief sort of overview of some things we can do with functions. And the purpose of this is we're going to look at buttons, and buttons have callbacks. So it's important to be comfortable with this stuff. Alrighty, see you soon. Alright, so we're almost there. This is the last session we're going to do before we start working on the project. Actually, you know, you're welcome to start working on a project anytime you want. I'd encourage that. But today we're going to have a look at buttons. So I'm going to go from the controller outwards, if that makes sense. So we go to the controller, and we have all of these functions, these high-level functions. I'm going to make a function called jump. And here's how it's going to work. I'm going to calculate just an x and y displacement. If I take 1 minus 2 times a random number, then that generates a random number between -1 and +1. Take that whole thing, multiply it by 10, and that gives us a random number between -10 and +10. Do the same thing for the y. And then we can tell the game context to move the player by that amount. Okay, cool. So we have that. Now the next thing I'm going to do is I'm going to make a function called setCallbacks. And that is going to send a message to the renderer context to say, hey, this is the jump function. This is where the jump function is. Okay, now I haven't written this function yet, but when I do, that will send this function into the view, and the view will send that to its buttons, and that is a function that will be called. Of course, we should remember after we initialize everything to set the callbacks. And yeah, that's sounding good. So let's head to the view. And I'm just going to define a few constants. I'll just paste them over. So we'll have an inactive color for the button, an active color, that's when the mouse is hovering over it, and a color for the text. Okay. I probably don't need this canvas class. That's one that I made, but I didn't end up using. It's basically the map view, but just without the rendering function. So let's make a button class. Okay, so most of the initializer here should be familiar from looking at the other classes in the previous video, but I guess this callback is important. At the moment this is set to none, but later on this will be set to a callable function. So I'll also make a set callback method, and I'll just head to config and we'll go from, oops, just import callable so I can use it in the type hinting. So callback should be a callable function which takes no parameters and returns nothing, because we're not going to use this for anything. I guess what I mean is it'll have a side effect, but it won't have a usable return value. So all we need to do is say self callback, set it equal to that callback function, and that's it. That is set. So then I want to make an update function for this. This is a sprite, so when I update a group, all the members of the group will be all the members of the group will be updated by calling this update function. And the way we pass in, it's fine. The way we pass in custom parameters is through this keyword arguments, which is a dictionary. So for instance, if I want to get the mouse position, let's say that's a tuple with an X and Y coordinate, we'll unpack it. So we look into keyword arguments, and we put in a string as the key, and the name of the variable that's been packed in there is the key, basically. So what else will we do? Let's go and check if that mouse position is inside the button. So we're working with the rectangle, and there's this collide point, which takes an X and Y, and if that occurs, then we'll do something. Otherwise, let's go ahead and make that button inactive by filling it with the inactive color. And I guess if the mouse is inside, then it should be active. Okay, so that's one thing. If the mouse is inside the button, it should be the active color. The other thing is if this is not just a mouse motion, but a mouse click event. So we can pretend that we can pack something else in there as well. So we'll search keyword arguments. If the click event parameter is true, we should check something else as well. We should check, and our callback is not none. That's important. If that's the case, then we can call the callback function. Okay, so see, that's it's nice and clean. So finally, we want a render function. There we have it. So we are basically just drawing the text onto our image. Okay, cool. So just thinking. All right, so we'll go back to the renderer, and the renderer needs to coordinate with these things. So when we go to create, where are we? Let's neaten this up a little bit. To create layouts, I'm going to add a sprite group here called buttons. Okay, so we make the status text, we add that in, and then we go over here, we're making the mini map, but before we make the mini map, I want to slot in that button. So I'm going to call this jump button. I think that's fine. Cool, so we make that button. Of course, we add it to our top bar horizontal stack, but we also add it to our buttons group. Okay, so then when we go later on, we're going to make a set jump callback. Okay, cool. So we set that, and I'm also going to give this renderer an update function. There we go. Okay, so as you can see, I'm taking these parameters and I'm bundling them into the keyword arguments, into the named arguments for the update function, and that is throwing that data along to each of the buttons so they can go ahead and update themselves. Alrighty, so I think all I need to do now is we render the status text, render the jump button, and that should be fine. Then we'll just need to go over to the controller again and check that we're calling update on the view. So just to check, let's give it a second. Anyway, it is understanding that this method is a valid method now. So we go over here and I'll just set a variable click event to be false, and then down here we'll say check if a mouse button click has occurred. Update. Now for the mouse position, we'll simply call Pygame mouse get position, and then for the click event we'll use that. Come on, that click event variable that we set earlier. Okay, fingers crossed. Let's give it a shot. Uh-oh, what's going on here? Okay. Oh, okay, because I'm using old code. I modified this a little bit. Just give me, this is on me. Let's give me 1 second. Okay, so the reason this is being weird is originally I wrote an add function which only had one of these offsets, not both of the offsets. So I'm just quickly updating it. So I'll go down to, okay, I think that should be working. Let's give that a go. Oh, 269. It's always fun finding these little things. Just adjusting the offsets and such. Alrighty, so if we run this right now, we've got everything we expected. And now here's the super cool thing. The super cool thing is as I move my mouse around, when it hits over the button pops off. And when I click it, the jump function is called. And this is fairly generic, so I could just pass in any callback function, it would run, and it does a pretty good job of detecting the mouse button as well. And yeah, the code is nice and clean, although the past few minutes of me fiddling around with it may not give that impression. You could always take this create layouts and break that out into more functions. Like this is getting a little bit much. You could break this out into a create status bar. You could even take status bar, make it its own thing. It's up to you. But yeah, there we have it. We have a game interface with widgets, widgets and layouts. So at this point, I would welcome you to come up with an idea for a game and go ahead and try and make it. In the next few videos, I'm going to make an example project, First Fantasy. It's a little Final Fantasy clone, but I really am keen to see what you guys can come up with. So, yeah. Make your modifications, make your project, upload it to the project gallery. And yeah, I'd really love to see it. All right, cheers. See ya. Hello, so at this point, we're done with the learning and we're going to start working on a project. Now, just because I'm stepping through the process with my project doesn't mean that you need to necessarily make the same sort of project. You're more than welcome to just run off, do your own stuff, use this for inspiration. Here's the finished product. So you have this game, we can walk around, talk to NPCs. My hovercraft is full of wheels. That's interesting. And we have these zones where battle triggers. We can go and attack. We can cast some spells. Let's heal ourselves. Let's not do that. Just give me a second, guys. Actually, let's go send a health potion. There we go. Still full of wheels. It's a wonderful day. Yes, it is. Okay, so that's a little preview of where we're going to go for the next five hours or so. Now, just a note that the videos are going to become a little bit less polished, a little bit less structured. Some of that's intentional, because the fact is that developing games is hard work. Even when the program is well scoped out and defined, it's still a lot of hard work. Now, when I filmed this, I was pretty much filming one stage per day. And sometimes I would just make something, and then the next day I would revisit that and say, okay, these are the new things I'm going to do, but I'm also going to go back and fix up the code. And that's a really important part of the natural process, and I didn't want to alter that at all, because it's the magic of development. So with all of that out of the way, yeah, let's get into the project. Let's do it. Alrighty, so let's get into the project now. This is going to be pretty big, so as they say, how do you eat an elephant? One bite at a time. In this first stage, I just want to basically load a map from a file and display the blocks on the ground and move the player around, and I'm also going to add a mini map. I'm not going to load any images, I'm just going to use flat colors. So let's get into it. I'm just going to grab a bit of old code. If I go to the finished section for buttons, grab all of that. And I'm going to make a folder called Stage 1. And you can see that here I actually have a text file ready to go. So I'll open this up, and here is the file. So we have the terrain header, and then each of these numbers represents a type of block. Each block is 32 by 32, I believe. Yep. 2 represents basically tree line, so we can't walk through 2. That's why you have it on the boundary. 0 is regular ground, and 1 is some sort of dangerous ground. Now in this game, it's going to be a Final Fantasy clone, but I'm going to make it sort of future dystopian, I guess, sort of like Fallout. So I'm going to call this dangerous ground. It's going to be radiated. I'm going to have radiated ground. We also are specifying the X and Y position of the player object. Okay, so nothing too intimidating right now. Let's just get back into it. So I'll open this up in Visual Studio Code, head to the main function, and just select my Python interpreter. Okay, so I'm going to go Model View Controller, I guess. Maybe the other way around. The other way around, Model Controller View. It really doesn't matter. So I'll go to the model file, and I'm going to define a number of constants. Okay, so these named constants are pretty much describing object types, and the first 3 are terrain types. They correspond to the level file, which will be useful. Now, if I look at the player object, I'm pretty happy with this. I'm just going to modify this a little bit. So instead of the player being 32 by 32, I'm going to make the player 24 pixels by 24. And in the player's move function, I'm not going to cap this anymore because, well, the tree line is already capping the player's movement, already blocking the player's movement, so I don't need to worry about that. Plus, in future sections, I may want the player to walk off the edge of the screen. I may want it. So, yep, the rest of this is fine. For the block, I'm happy with this. This block looks good. Now, the game logic, a lot is going to change. I'm going to get rid of all of these groups, and I'm going to make a dictionary called terrain, which holds groups for each of the terrain types. So we have a dictionary. The keys are the terrain types, and the values are sprite groups. And then I'm going to have another sprite group, which I'm going to call transient state. So let's say that we go ahead and we load a new level. Of course, we want all of the terrain and environment to change, but we want the player object to be consistent, to be persistent. Well, I mean, I guess technically we don't have to. It's one approach or the other, but I'm going to go ahead with this one. So we'll have, I'll call this transient state. And I'm not going to worry about that. Okay, reset state, and I'm not going to load a random state. If we go here to reset state, we will loop through the transient state and kill everything in there. That will remove it from each of these groups as well. Okay, now instead of loading random state, I'm going to load from a file. So I'll make this function. And this is going to bring in the sort of code that we looked at in the first session. So we'll open that file. And that will be scoped to this block of code. So once this block of code ends, the file will be automatically closed. Okay, so we're just checking that the first line we see is in fact the header. It should be. That's how my format is going to work. And then, of course, we'll strip out the white space and remove the angled brackets at the start and the end. Then we look at the contents. I'll just leave the player for now. I'll just render all of the terrain, and then I'll worry about the player and the minimap. Right, so we're going to make this load terrain data function. In order to use this type hint, I'll need to import the IO library, no problem. Okay, so this row variable is basically keeping track of the y coordinate that we're writing to, because each line is a new y coordinate. Okay, so we'll check for the header as well. If we read a line and it's the beginning of a new header, then no problem. Simply return that line and the function will deal with it. Get rid of the trailing new line. And then we expect to have a whole bunch of numbers separated by spaces, so split based on the spaces. Okay, so if we get to this point and everything is working just fine, then we could expect line to now be a list of strings, and each string just holds a single character. That's the number. So let's say we're on this line here, that is, we're on row 1, 0, 1, 2, we're on row 1. As we loop through here, we want the column to increase because we want to increase our x coordinates. So no problem. We can simply say for column, and really this number indicates the type of block that we're laying down for the terrain. We get this by enumerating. Remember, enumerate returns a tuple where the first element is the position in the loop and the second element is the underlying object. Okay, so we'll just convert that from a string to an integer. Then we'll make a new block. Okay, so we don't need to store a variable for the block type or anything. We sort of know what block type we've got. We can use that to make a decision about which sprite group to add this to. But we should check, first of all, that it's valid. So our test is if the block type is not one of the keys in the dictionary. Okay, but provided that passes, then we can write this in. So we go self-terrain. So add it to the appropriate group and also add it to the transient state no matter what. But yeah, that is the function. Of course, if we get to the end of everything and that's it, then simply return the blank string indicating that we have reached the end of the file. Okay, so we will write a load player function, but not yet. Now let's look at can move. We can simplify this quite a bit. So we don't need any of this because we're not going to loop through all of the blocks. We're just going to check to see if any block was hit. That's it. So the player's trying to move. Yeah, let's go with that. Player can move. Okay, so the player's trying to move and we want to check this against the blocked terrain. And then we don't need to do these extra checks. We don't need to activate or deactivate blocks. We can just return whether this group was empty or not. And that's it. Nice and simple. Okay, get player, that's fine. This active blocks, inactive blocks. Let's not do that. Let's call this get terrain. And this will return a dictionary where the keys are integers and the values are those sprite groups. Okay, good. Just double checking. Yep, that is fine. Okay. So now we can go over to the controller and adapt it. Oh, also, let's check config. Yes, we don't need these block statuses. Yeah, that's fine. Okay, so looking at the controller, we can probably simplify this a little bit, or change it at least. Yeah, so let's go. Yeah, let's not do any of this. Let's not make a jump function or set the callbacks. We'll get rid of all of that. That's fine. What we will do is tell the game context to load from this file. The file name is levels forest.txt. Going to get rid of this movement speed because it turns out that 1 works okay. And what we can do is, I mean, it doesn't really make sense. It doesn't really make sense to encode the player's movement speed in the controller, in the app. That's a bit weird. So we can modify this later on, but modify it in the model area. But anyway, I'm going to bring these together because it could be that there's a whole bunch of keys that we're checking. So this would be a more appropriate grouping if you're pedantic about things, as I sometimes am. So that's fine. Okay, now I might add this in again later on, but right now I'm not going to worry about click events or this refresh button or updating the buttons anyway. That's fine. So I'm going to draw this, and right now I'm just going to send in the terrain. Okay, so now let's go to the view. I'll just modify this a little bit. Okay, so I'm going to change this to terrain colors. Now for the keys, I'm going to reference the constants that were set up in the model module. So I'll go model, terrain, ground. I'm going to leave these layouts. I'm not going to use layouts in the map, the game map, the top-down view of just walking around, because it's a little bit of overkill. Okay, now for the render function, this is the part that I'm going to modify. So right now, we'll just say, just care about terrain. Like I said, that's a dictionary where the keys are integers and the values are sprite groups. So of course we'll go ahead, fill the screen, but I'm going to actually simplify this quite a bit. So terrain is a dictionary, so we can loop through the keys of the dictionary. So we can say for block type in terrain. So that'll be automatically looping through like ground, radiated, blocked, etc. Okay, so we can use that block type as a key into the dictionary, and then we can, well, when we send in the key, that is accessing the underlying sprite group, we can get its list of sprites and loop through those. And we can also use that to access into the images dictionary. Okay, so see, that's quite a bit simpler. Okay. Happy with that, we can bring that in. Status view, that's fine. I won't mess with that too much at the moment. Probably won't use it, but it's good to have it anyway, maybe. Minimap, I'm actually going to leave that for now, so I'll just comment that out. I'll come back to that in a second. Yeah, again, button, okay, nice to have it. I'll just leave it, I'm not using it right now. Renderer, okay, so this is going to have to change. Okay, good. So again, we populate the dictionary with a bunch of blank surfaces, and then go through and fill each of those surfaces with the appropriate color. Okay. So the layouts, I'm going to change this quite a bit. Oh, I just remembered something else. Also, in the config, this will just be 480. There we go. Right, so where was I? In the layouts. Let's just clear all of this. So at the moment, we're just going to have a map view. So for the rectangle, and then why not, we'll set the default color to black, and we'll pass in our images. Okay. That's good. We can get rid of all of this. And then just modify the draw function. Okay, good. So the render function writes to the map view's image surface, and then the map view has its own rectangle, so it knows how to get drawn, basically. Okay. All right, so nice and simple. Let's see how this goes. Huh. What do we have here? Oh, yeah, of course. 74 in model. So I wonder how I missed those things, but there we go. We add it to the group. Invalid. It's probably because I'm partially loading the file. So I'll just go back up here and we'll say, if we see the player header, just end, just return. There we go, finally. Okay, cool. Oh, seems a little off. Oh, okay, I just remembered. If we go to the model, previously I was specifying the XY as the center, but really this XY should just be the X and Y. Alrighty, so it's been a bit of a journey. We've got that done. So now this XY is indeed the top left corner. And if we give this a shot now, there we go. Okay, so we can see if we compare this to the file. If we compare this to the file, it is loading the level. All right, so let's bring in the player. So we'll just go to the model. So we have load terrain data, and we'll make a new function, load player data. Okay, so we have the player object. That's fine. What this load player data will be doing is reading lines and then setting various properties. So if we look over at the file, for instance, here we have X and Y. So we'll be setting the X and Y coordinates of the player object. Okay, so just the same as before. Let's grab this stuff. Okay, so we'll grab the line, and if it's a header, then yep, we'll throw that back to the controlling function. We'll get rid of, the trailing white space, and here I'm going to partition the line. It really does the same thing. And we'll have, Okay, so if we look at this line, for instance, we have property, something, and value. If we look at this first line, X will be the property, the space is a separator, that's the middle argument there, and the final argument is the value for that property. So we've set that up. Now we don't need this loop here. So what do we have? We have X and Y, so we can say if that property matches X, do something. Otherwise, if it matches Y, do something else. Otherwise, raise an exception. Okay, so I'll just be setting these properties directly, as you can see. And yeah, that is it. So we can close that. And then we can go back to our loading function. And we can send that out. Okay, cool. So now in the render function, if we go to the controller, I'm going to pass in an extra parameter, say player, pass that through. Okay, so now it's onto the view. So go to the view, and currently we've just got the terrain. Let's get the player as well. Okay, so we're passing that along. Then we go to the map view. I know there's a lot of back and forth at the moment, but that's programming, that's how it is. It's better to make things one step at a time, see how it goes, adjust it. It's a lot of fun too. I like to program in cafes, just grab some coffee and do your thing. Okay, cool. So we loop through all of the we loop through all of the blocks. Now we'll look at the player object. So we'll say oops, what am I thinking? So that's the image that we're sending through, and the rectangle we're sending is the player's rectangle. Now we can probably just go rect. Okay, cool. So that should be ready. We can give that a crack. There we have it. We can see the player, but we might have a really big level, in which case we might want to see more of the level, which is where a mini-map might come in. So I'm going to make a mini-map widget and blit it just up on the top right corner. No problem. In order to do that, we'll need to modify the mini-map view. Now what I'll do right now is I'll grab this render code because I'm pretty happy with that, and I'll go to the mini-map view class that I have and just put this in here. Okay, so things are going to get a little technical here because I'm going to have a mini-map. I guess it'll be, in this case, 128 by 128 pixels. I'm going to be drawing some images. I'm going to need to do a few things. I'm going to need to scale the images so that they will fit in a reasonable space. And I mean, that's the big one. So currently the way this initializer works is we get all of this information, and that's pretty good. I'm happy with that. What I want to do is I want to take not the original dictionary, but make a copy of the dictionary, because then I want to take all the images in that dictionary and shrink them down. So I'll make a function called scale images, and that's what I'll implement down below. So this is sort of a percentage thing. We've got, let's say 128 pixels is our width, 640 pixels is the screen's width, and this just gives us a neat scaling factor. I'm gonna have the same scaling factor for both the X and the Y. Otherwise things will be just the aspect ratio will be wrong because the mini-map's a square and the screen that we're seeing is a rectangle. It's a bit weird. We'll just go with this. So what we'll do is we'll loop through the images. Now the images are a dictionary, so if we loop through, we'll be looping through the keys of the dictionary, and those will be, we can call them image types. So go for image type in Okay, so I'm just calculating the new width and height of each image. And then we can go ahead and write that back into the dictionary. Okay, and yeah, that's it. So we end up with a copy of the original image dictionary, image library, but each of the images has been appropriately scaled so that it won't be too big in the minimap. So now we can look at the render function. Before we go and loop through each of the blocks, we'll need to work out sort of the translations which will be used. We're basically going to subtract the player's position, then scale everything, and then shift it so that it will be in the center of the screen. So first of all, it's a good idea to get the player's rectangle, and then we can go ahead and get the displacements which will be used to subtract the player's position. So of course that'll just be, if we go to the player rect center X and negate that, that's the translation to the center of the player. Then I'm going to recalculate, I'm going to get the scale factor. So that will be used for scaling the factor, the positions, and then I'll get the center position, which is really go self width divide by 2. That will set it so that 0, 0 is the center of the minimap. Okay, now we can look through. So again, first step is we translate by subtracting the player's position. Then we multiply those positions so that the blocks are lining up properly. Because if we have one block and then another block, that difference is still, the difference in the X values, for instance, is still 64 pixels, 32 pixels or something. We need to hit that with the appropriate scale factor to get that, get the blocks next to each other on the minimap. Then I'm going to move it so that it is centered in the center of the minimap. But yeah, that's it. So just pass through the translated rectangle, and that is pretty much all we need. Then we'll do the same routine down here for the player. So we'll say and yeah, too easy. A little bit weird, but takes a bit of experimentation, and this seems to be working okay. Okay. So we can close that down and go to create layouts. where we'll have the minimap view. Okay, good. So we're setting it 128 pixels to the left of the right edge of the screen, width and height of 128. That looks fine. Okay, so then when we go to render, then we'll pretty much do the same thing. Render that, and then we will also blit that to the screen. There we go. Okay, so read off the image in rectangle, blit that onto the screen, should handle it just fine. What do we got here? 165 in render. We don't have self-image? Oh, shouldn't be original image, should just be image. There we go. There we go, okay. But something doesn't seem right. Let me check that again. Oh, the rectangle hasn't been set properly. For one thing. Or we can just go copy the rect from the argument. Yep, okay. I love these little bits of dialogue as I'm making things. Okay, that's a little better. That's a little better. Let's keep working on that. Oh, here we go. Yeah, the dy should be based on the center y, not the center x. See how that goes. Okay, so the player is the center of the screen. As the player moves, the minimap is centered around the player. Now there are some weird effects here. Probably comes down to non-integer division. The numbers don't quite divide. There's little gaps. I don't know. Personally, I'm okay with that, but we could always, let me just try troubleshoot this, see if this makes a difference. We could always ignore, not cast it to an integer. Ah, doesn't make a difference. Okay. Okay, cool. Anyway, there we have it. So currently we're loading our map from a file and we are viewing the original map and a scaled down mini map version. Cool. Now it would be great. By the way, our game's going to have two modes. So we're going to have walking mode like this, adventuring mode, and then when we hop into this radiated ground, there's going to be a probability that a monster will come out and attack us, in which case we'll flip over into battle mode. I'm also going to make a bunch of objects that we can interact with, get random loot, and we'll add an NPC that walks around and we can talk with them. So that'll be the focus of the next stage, is adding the NPC. All right, have a good one. All right, so let's move on to next stage of development. I want to make NPCs. I want to make little villagers that walk around and I can talk to them as well. Just checking through here, this config looks good. Now I'll go through the usual development, which is we do it in stages. I'll start with model, and of course we're going to need to define a constant for the view class to refer to these. And I'm also going to make a bunch of variables, a bunch of constants. So I'm actually going to paste these in because it's a lot of typing. So here I'm just defining basically all of the directions that we could be looking in, and I'm also giving them a lookup dictionary. Note that I'm also specifying a direction of none. And the reason I'm specifying that is if we look in this tuple here, this is going to be a tuple that the NPC, when they choose a direction to walk in, is going to choose from one of these. And so I need to have not walking as an option. Okay, so that is fine. I'll just go ahead. Oh, and I'm going to make one change here. I need to know which direction the player is facing. Doesn't matter at the moment what we start this as, but I'm going to set it up so that we remember when we move which direction we're now facing. Because when the player interacts with something, they'll check the area in front of them, so we need to know which direction that area is in. But yeah, otherwise that is good. I'm actually going to grab all of this, and I'm going to use it for the NPC class. But before we get into that, I'm going to make a bunch of dialogue for the NPC. Now, we could save these as hard-coded strings within the class, and that's perfectly okay. But I'm going to take a different approach. I'm going to make a file and load from that. So I'm going to make a folder, call that dialogue, and then inside that folder, I'm going to make a file called basic.txt. And this is going to have a whole bunch of sayings. So what do we have? Some things we can say. Are there any Neil Breen fans here? Or is that It's a Magical Day? I forget. But yep, that's something a villager could say. Maybe the villager is saying, hey, watch out for monsters. Okay. And is this The Simpsons? I don't know. My hovercraft is full of wheels. Ooh, maybe that's a villager from the future. So it doesn't matter. Each line here is a new dialogue line, and I want to set it up so that when we want to talk to an NPC, the NPC will select one of these randomly and print it out. Okay, so just go back to the model. So now we're also going to have to specify which file name contains the dialogue that we're after. No, whoops, it's already been set up above. Okay, so I'm going to make a few other variables. The purpose of these variables here is when the NPC walks, they increment the action time, and when that matches the maximum time for that movement, then they choose a new action. I'll make another function, not there, called choose action, and define that down here. Okay, so let's set our direction. So I want to look into the directions dictionary, and I'm going to choose the key randomly. So I'll go random choice. Now that takes a set, and the set I'm going to look at is the set of allowed NPC directions. So we choose one of those directions, and that is our direction variable. Of course, we'll reset our time for that action, and we'll randomly choose an amount of frames to perform that action. I guess anything between 1/4 of a second to 3 seconds would be fine. Okay, cool. So let's close that, and this one here. Next thing I want to do is I want to make a function which randomly chooses some dialogue. Okay, so pretty straightforward. We just open up our dialog file, we look through it and put all the valid lines into that set, that list, and then we randomly choose a line from there and pop it back. Okay, now the move function. Now, I'm going to be a little bit dodgy, and I'm going to put the update code in the move function, just because this is a function which we know is being called once every frame, so why not? Okay, good. So we're just we're just choosing a action. Now we don't save the direction, that's fine. But yeah, that looks good. So we simply take that amount, and we do need to take this because we still need to be able to possibly move the villager one step backwards if they've stepped into a forbidden zone, if that makes sense. Okay, yeah, get rectangle, that is fine. So far so good, but of course, how are we even going to have villagers in this game? We need to load them from a file. If we go to the levels file, the forest level, I'm going to make a new header called interactables. So this is just anything we can interact with. At the moment it's NPCs, but later on we'll also be adding radioactive barrels that we can search through. Those will be interactables as well. So the way this works is, let's say we want to go NPC and then all of the arguments, the X, the Y, and the dialog file path. So let's make an NPC at X equals 96, Y equals 350, and dialog basic.txt is the file path. And then let's make a second NPC, 200. Cool. So we've got 2 NPCs. The next thing we need to do is modify the game logic class so that it can load those NPCs. We have load from file, load terrain data, load player data. Okay, so I'm going to take a copy of this load player data and modify that to load the interactable data. Okay, so if the tag is interactables, then we'll go ahead and call that function. So just step through here. If we have got a new header, then return that. Of course, remove the trailing new line. And now what I want to do is, let's see, I want to break apart those brackets. So I want to split it based on the opening bracket. So I'm going to call this object, and then the bracket, and then the arguments. Okay, and then I'll work on the arguments. So when I call this, arguments will be populated with everything from the end up to the opening bracket. So that's all of this stuff with that closing bracket as well. So then we can say, okay, Yes, we have arguments, then the closing bracket, and the stuff after the closing bracket. And we'll get this by partitioning. Then I just want to remove any white space if it is present. And finally, I want to split this with the comma as the delimiter. So at this point, we'll have this stuff here inside the brackets with any space removed. Then I just want to split based on the commas. There we go. Okay. So now let's keep working here. So if argument is NPC, then go ahead and do something. Otherwise, that's all we've got at the moment. Okay. Now, I'm going to make another sprite group here. So we'll go back up to the initializer and we'll make a group called villages. There we have it. Okay. Okay, so here we have it. Arguments is now a list with strings. So for the x, we want to convert argument 0 into a float, or arguments. For the y, we'll convert arguments 1. And then for the file name, we can just pass in arguments too. It's okay if it's a string, that is fine. Okay, so we've made the new NPC and we'll add it to the groups. Okay. Seems all right. So that is loading, creating the villages. Now, all of these movement functions are going to have to change. So at the moment, the only thing we're checking is the blocked terrain, but that's going to have to change because we also want to check against the NPCs. So let's go, if we have hit something, so the length of that is not 0, then we know, we know we can't move, but otherwise we'll need to check against the villages, because the villages are going to block the player movement as well. And I'll call that hit blocks, why not? So we've got that, but then remember the villages are also going to be moving. So this is player can move, will make a NPC can move. Okay, so just like before, I want to match this against, I want to match this against the blocked terrain. But then I'm also going to say, okay, well, the radiated ground is probably somewhere where an NPC wouldn't want to go. There's monsters and stuff in there, so we're also going to turn around if we see any radiated ground. And finally, I'm going to check this against the player. So if we go... So I'm just checking if these two rectangles are colliding with each other, and if they are not colliding with each other, then we can move. Otherwise, that should be fine. Now, we could say, hey, well, what about the other NPCs? So does this mean that we can have villagers like walking through each other? Look, it's not a perfect system, but I'm going to accept it at this point in time. It's pretty easy. There are other checks we can do, but I'm happy with this. So close that. So here we're moving the player. Let's make a copy of this. Actually, let's not do that just yet. Let's make another function called make player interact. Okay, so what are we going to do? Well, I want to take a copy of the player's collision rectangle, move it one step forward, and check if anything is sitting in that spot. So I'm going to make some variables. I'll go dx, I guess. Okay, so direction is 1, -1, or 0, I guess. So this is 24 times that. That's going 24 steps forwards, or 1 player width. And then the same thing here. Okay, good. So this is returning a copy which has been moved. And then we can go ahead and look at these. Okay, so I'm also, as well as getting a dialogue line from the villager, I'm also going to make the villager stop walking. So that would make sense. If you talk to a villager, they stop, they talk to you, maybe they wait a little bit more, then they start walking again. Okay, so then I'll make an update function, which really is going to just tell all the villagers to walk. So if the villager walks and hits something and then can't move, it would make sense to also choose a new action, which is what we're doing here. Alrighty, so what do I want to do? I want to be able to get the villagers in order to render. That's looking good, and now we can look at the model, the controller, I mean. So we'll just, yeah, again, just the overview. So the villagers can walk around, and when the player hits spacebar, we'll try to talk to a villager, and if a villager is nearby and they're facing towards them, then we'll get a line of dialogue. Alrighty, so all of this looks okay. It's down here in the run function, basically. So let me check, basically, are we hitting space? Okay, so make the player interact. Then we'll handle the keys, and we will update to make the NPCs move, and then we'll go ahead and draw everything. Okay, I'm also going to have another argument, which is the group, the sprite group of the villagers. Okay, so it's a good idea. It's a good idea just to run this. As a matter of fact, I wonder if this works. Yeah, good idea just to quickly run this and check we've made no errors. Okay, good, no errors at this point. So we can go ahead and proceed to the view. Just checking here, we can add another constant. But I'm really just going to reuse the background highlight color. It's a nice light blue. I'm happy with that. Okay, so what do we have? We have these stacks. They're fine. We don't need those. This map view. So the map view, I want to take the villagers. good. Yeah, so we're going to have to create this image later on in the view class, but in the renderer class. But yep, that is looking good. Then we'll go ahead and do the same thing in the minimap view. So we'll go down. Yeah, so we make sure that we're taking the villages as an argument, and we're using that down here. So yep, so just as before, we move it according to the player's position, scale it accordingly, and then move it to the center of the image, and we'll use that down here in rendering. But yeah, very simple, very straightforward. There it is. And the rest should be fine. So we can close that up. Then when we go to the renderer, we're going to need to make another image here. Good, so we make another image, add another image to the dictionary and fill it in with the appropriate color. And then we'll need to go to, will we? No, the layouts are fine. It's the render function, or the draw function down here. So we'll also take the villages. Okay, so fingers crossed, moment of truth. We'll head to the main function, give this a shot. Okay, so you can see we have the villagers walking around, and they are there on the minimap as well. See, so we hit space, and the villagers say something, and when they speak, they stop walking for a second. Come on. Yep, there we go. Starts walking again. This one doesn't. There we go. Yep, the other one talks as well. Yeah. There we go. So, finally, we're getting there. Finally, instead of printing these out to the terminal, I want to pop a dialog box up here. But remember, in Final Fantasy, whatever, oh, I'm sorry, we're not doing that. This is our own game. The game action will sort of pause while the text is here. So basically, I'm going to need to introduce a new variable for the model, and that is the game mode. Okay, so again, we'll take it from the top. We'll go back to the model module and define some more constants. And then if you wanted to extend this and add inventory management and all of that stuff, then you could add another mode as well. It's pretty similar. Okay, so we should probably add getters and setters for the mode. When the game starts, we'll go. Actually, we should probably. It's fine. It doesn't matter at this point. So we'll go self mode. Going to start in walking mode. Okay, so we've got getters and setters for the mode, but I also want to make another variable to track the current dialogue line, because when we render this, we're going to need to know what the player is saying. So that's the speech line, which is currently happening. And then we'll add that here. Okay, good. And in the interact function, that is where we will set that state. as well as when the villager starts speaking, we'll set the mode to talking mode. Okay, cool. So we'll head to the controller and make a few variations on this. Okay, so let's say we've hit space. Do we want to try to interact? Well, we can, sorry. Oh, weird. We can only interact if we're in walking mode. Otherwise, what can we do? So we'll go, if we'll get the game contexts mode. If that is walking mode, then go ahead and try to interact. Otherwise, well, we must be in talking mode, and if we're in talking mode and we hit space, let's say that closes the dialogue. So we can go ahead, set it into walking mode. Okay, now how about rendering? Well, if we're in walking mode, then we'll do all of the, walking around, making the NPCs walk and everything, and also we'll set a blank line of dialogue. Otherwise, we'll ask the game context, hey, what did the NPC say? And then we'll pass that dialogue along to the draw function. And then the draw function will have a test to say, hey, did you just pass in an empty line? No problem, we won't do anything. But if you did pass in a line, then we'll display a dialogue panel. Okay, so we'll head to that now. We're almost done. I'm just going to make a new widget, and this will be a variation on the status view. Yep, I'm happy with that. We'll just get rid of this scroll X stuff. We don't need that. And then in the render, we'll take in a line. So won't worry about the scrolling. And all of this looks fine. Just for the text, we'll take that string which we were told to render. And I think we'll go 32 pixels across, 8 pixels down from the top. That's probably fine. Good. Okay, nice and painless. So we can then go to the create layouts. And I just realized something else. This will look a bit dodgy, but see, we've got screen text color is black and text panel color is black. That's very dodgy. So I'll just set these to white. There we go. Okay, cool. So anyway, where was I? Okay, so create layouts. Okay, good. So we make that dialog view there with a width of 512, height of 64, 64 pixels from the bottom of the screen. Anyway, should be familiar with this. Now I'm also going to take in the dialog line currently, if there is one. So we do all of this, and then we say, okay, if we've got a line, yeah, render it and then bleed it to the screen if there's a line. Okay, again, Moment of truth. Let's give this a shot. I'm surprised. There's been not a lot of errors in this session. Okay, so we move along. Come on, come on. Oh, there we go. Okay, cool. So the dialogue comes up. My hovercraft is full of wheels. Of course, in RPG games, the text doesn't just appear, it scrolls, but we can leave that as an extension exercise. I don't want this to be a 24-hour course. Yeah, let's test it on the other NPC. There we go. Oh, it's a little bit patchy. There we go. Watch out for monsters. Thanks for the advice. I will. As in, I'll try to get into a fight. But, yeah. Come on. Again. Watch out for monsters. Okay. Cool. So that's fun. In the next session, yeah, so there will be barrels that we can look in and they'll give us items, but I guess we'll revisit that. I want to go into combat mode. So we'll set it up so that when we walk around in these blocks, it can randomly put us into combat mode. Actually, just double thinking, might be a good idea just to make combat mode first and then make the transition. Okay. Alrighty, so see you again soon. Bye. Alright, so what we want to do now is get the combat mode working. Now it's going to be pretty simple, pretty basic at the moment. I pretty much just want to display maybe a background and some monsters and my party members and nothing else right now. Mostly this is just setting the infrastructure up. So to start with, see I have model and view. I'm going to make copies of those. So this model is really referring to the adventure mode of the game. So we'll relabel that, and note that if we go to controller, we can see that it is Visual Studio Code has refactored that as well. So then we'll go to view and we'll do the same thing. Okay, that's fine. And then I'll go down to, actually I'm going to change this around a little bit. So see I have this run function. I'm going to grab that. And maybe if this program was getting bigger, we could actually split and have different controller classes as well. But I'm pretty happy with this. So what I'll do is I'll grab these contexts and actually put them into the run function. Because depending on which mode the game is in, the game context or render context could be referring to different things. I'm also going to grab this code here and execute that. Execute that here. Okay, then I'm going to grab the original run function. I'm going to rename this run function to adventure main loop. And I'll enter into that on the run. Okay, cool. Now I'm just going to have to do a whole bunch of refactoring. That shouldn't take a second. I will rename this. Okay, cool. So just double check the other ones. Yep, this all looks fine, no errors. Okay, excellent. So now I'm going to just add a new file, which I'll call battle data. Okay, so when we enter into battle mode, we need to load in a bunch of data about the scenario that we're playing. And how this fits into the bigger context is when the adventure mode decides that it's time to transition into battle mode, it will write a text file with all the information that we need to complete the battle. So what could we include in battle data? Well, of course, we'll have a description of the enemy types involved in the battle, as well as the members of the party. See that each member tag indicates specification for one party member. When we start the next party member, we'll have another member tag. And also the inventory. And what are bones? Their bones are their money. And so are the worms. No, it's money, basically. Okay, so. Yep, that's fine. Now we'll just make two new files. Have combat model and combat view. Okay, and then we'll go back to controller and we'll also import those combat files. Okay, and I'll make another copy of this adventure main loop, which will be the combat main loop. Okay, cool. And yeah, and let's jump into that from the main function. Okay, cool. Right, just double checking all of that. Now again, at the moment, we are pretty much going to have no events, so we can just get rid of that right now, keep it nice and simple. And we don't need any of this either. We're not checking walking mode or anything like that. Okay, so where was I? Alrighty, let's talk about this. So in a combat situation, we have two rows. One row is the members of the enemy party. The other row, I should say columns, shouldn't I, is the members of our party. I'm going to... It doesn't quite seem right, does it? It should understand what that is. I'll have a look at that in a second. Oh, what am I thinking? I haven't even pasted the code. Okay, never mind. What am I saying? Okay, recollect my thoughts. So in the adventure mode, we were using Sprite Groups because I guess it's good. It's a handy way of handling things. And all of the villages have nothing to do with each other. But when you're looking at a combat situation, you have columns, the enemy column and the good guy column. I'm going to use a linked list. And a linked list can be referred to by its head. So we'll have the leader of each column is the argument that we pass through to the renderer function. Okay, so that's probably enough work on this controller. It's very simple. We'll head over to the model and I'll grab all of this and paste it over, and we'll work at this one step at a time. So we don't need terrain. Instead of that, for the basic object types, these will be the character types. So what do we have? We have soldier, mage is the other party member, and then we have rats and cultists. We don't have directions. At the moment we don't have modes either, but I'll just go ahead and put this in. There we go. Okay, so later on when we go to make enemies, we will need to randomly generate their health, and based on the enemy type we'll need to know what are the minimum and maximum health amounts. I won't bother with generating magic. We could have enemies that cast spells, but I'll keep it simple right now. Okay, so then we have our, should also make some other constants for item types. There we go. We'll use that later on in the inventory. Now, in the adventure mode, our types were Pygame sprites because we needed to do collision checks on them. We don't need to do collision checks on combat sprites because it's all handled by the logic. There's no dodging or anything. It's all automatically calculated. And this actually lets us simplify things quite a bit. So I'm actually going to go ahead and type this out and then talk through it. Okay, so I ended up pasting all of that. Oh, we also don't need X and Y. That's fine. Get rid of that. Make it nice and simple. So because characters are going to be used in linked lists, they need a reference to the next character in the list. With this, we come to a dilemma. We're currently working in the character class. So in this set next, the class type of next, it should be an instance of character. But wait a second, can we do this? Because we're still defining the character class. This is what's called a forward reference. That's where you refer to an instance of your own class before you finish the class definition. Now, you can do this in Python. All we need to do, there's two approaches. One is to enclose this in a string. And Python says, okay, all right, I trust you. But this only is really, this is only works in, well, it does work, but there's a better solution. And the better solution is we go from futures, that's 2 underscores there, import annotations, or is it future? There we go, from future, import annotations. And this is just a bunch of, I guess, planned future features which aren't core Python yet. One of those is forward references. So if we import annotations, then forward references are allowed. It hasn't been implemented in core Python yet. The issue is this won't work in, I believe, Python 3.7 and below, or 3.6 and below or something, which is where the string approach would be necessary. But otherwise, as you can see here, we are just defining a whole bunch of getters and setters. And you don't need to do this. You can work directly with these variables. If I preface this with an underscore, that's sort of a sign that we shouldn't be working directly with the variable, but otherwise we could. I just wanted to include these getters and setters to make the code neat. Yeah, completely optional, and it's pretty much what you expect, get and set anyway. Okay, so that is the character class done, and the character class will actually sort of handle everything. So we can go ahead and get rid of all of these other classes. We don't need them. Okay. So we do not need any of this. So for the game logic, when we create it, we simply reset its state. Now, when we reset the state, we're going to hold three things: a pointer or a reference to the first party member, a reference to the first enemy of that other group, and an inventory dictionary. Okay, good. So we can close that. Now, these load from file functions are going to be a bit different, but at the same time, they're going to be very similar. It's variations on a theme. It's the same stuff we've been doing before. So I'll go ahead and populate these, then I'll talk through them briefly. Okay, so all we're doing here is we've got in battle data a bunch of new header types. So we're just checking those with the if-else statements here. Okay, so pretty straightforward. What we're doing here at the point is to choose the enemy type and name to give to this new enemy that we're about to construct, and we can now go ahead and construct that. So there we have it. We construct the character. Now this bit here is a little tricky. Essentially what we're doing is inserting at the head of the linked list. So how would that work? We get whatever is currently the head, and then say for that new enemy coming in, your next thing is the current head of the list, and then set the current head of the list so it's pointing at that new enemy. Think about it a few times, and it's okay even if this variable is none at the moment, because when we reach the end of the list, the next member would be none anyway. So that is perfectly fine. And we just go ahead, randomly generate some HP, set some properties, and there we go. That's the enemy. So that's fine. We can leave that and look at the player data. Okay, so as you can see, we do the same trick because we are inserting a new party member. Now, implicitly in the file format is the fact that every time we see this member header, we should create and insert a member. And then these lines down below are setting the properties of that member. Okay, cool. So we start setting some properties. As you can see, here we're setting the name and the type, and yeah, it's pretty good. So far, so good. Okay, cool. So here we are setting various parameters. Alrighty, no worries. Okay, so that is the member function. We can go ahead and close that. Finally, we have the inventory function. Okay, cool. So we just look through, we do some if-elif to decide which sort of item we're inserting into the inventory. Then we go ahead and declare its quantity in the inventory. Cool. Okay. So I'm happy with that. And we can get rid of all these move functions. So this is going to get quite a bit simpler. Okay, cool. These getters should be pretty straightforward. That's all we need. So we can get rid of all of this. I guess we'll be fleshing this out later on, but for now I just want to get the thing working. Okay, that's good. So we'll head over to the view class. Oh, yeah. Let's fill this in with some code. Pretty happy with these colors. I guess we don't need NPC color. We don't have any NPCs. And I'm going to change the text panel to that light blue. Okay, so I'm going to call this character colors. Okay, cool. And I'll just give them some very simple values for now. Okay, now as well as that, I'm going to need some terrain colors. And then for the ground color, just go over to the adventure view and grab that, yeah, that brown color there. Okay, cool. Yeah, I'm happy with the rest of that. Alrighty. So the stacks, yeah, they're fine. The map view, gonna have to alter. Okay, cool. So instead of simply filling with a single background color, I'm going to generate a surface which represents the background. It will have the same size and orientation and everything as the full rectangle of the object, but the first half of it will be filled with the sky. Then we move that rectangle down to the second half and fill the image in with the ground. Okay. At the moment, I'm just going to remove all of the arguments for render, and we're just basically going to check that this works. So yeah, get rid of all of this. And yeah, just split the background on top. Okay, so that's fine. I'm going to get rid of status view. Might add it in later, but we already have a copy of it in the adventure view module anyway. We're definitely not going to need minimap view. Keep button. I'm pretty sure I'm going to need that later. Alright, so onto the renderer. So we'll just head over to the okay, cool. So we just loop through the dictionary keys and use that to index into here and fill all of these. No worries. Okay. And here when we create layouts, we're going to keep it nice and simple. I guess we just don't need a background color anymore. Okay. Cool, so that's all we have at the moment. This is just drawing the background and then draw that to the screen. Let's give that a go and see which errors we made, because it... Oh, okay. Okay, key error low. Very interesting. Let's check that out. Combat model, HP generators, min max. Yeah, let's change that. Let's change it to low and high, I think it was. Okay, cool. So as you can see, yeah, it's drawing that just fine. Okay. So now onto the rendering the objects. Okay, so we want to traverse a linked list and draw everything which is valid. So let's just do the enemies for now, check that that's working. Okay, so yeah, the main thing for traversing through a linked list is we start at the head of the list And then when we hit none, that indicates that we've reached the end of the list. And then after each iteration, we go to the next, each member's next member. That'll step through it. So the cursor sort of starts off at the skyline of the screen and steps back towards the camera, if that makes sense. And yeah, we draw the enemy. So give that a go, see how that looks. Ha ha ha. What's going on here? Oh yeah, of course. What am I thinking? We need to pass that data in. Give that a go. And there we have it. We can see our enemies. Okay, so let's modify this and make the players. Okay, so double checking everything. So I have included the X and Y for the rectangle, just in case we want to apply a modification. That'll make sure that everything's drawing in place. But otherwise, it's really just the same as before, just with member instead of enemy. So let's give that a go. Yeah, there it is. So we can see the enemy party and our party here. Okay, cool. So that's very good. In the next stage, we're going to look at actually incorporating a menu in here so we can attack and do some basic AI for the enemy. And yeah, that'll be it. Alrighty. See you in the next one. Bye. Okay, so originally the goal was to get the whole combat system working, but that's just taking a bit of time. So to start with, let's get the attack system working. We will do a bit of stuff on the combat system as well. To start with, keep it nice and easy. I'm just going to go to the combat model, and here we have these health generators. I'm also going to make some damage generators, parameters to generate random damage numbers. Alrighty, cool. So we've got the damage there. Now I'm going to make a bunch of modes. And I'm actually going to paste this in, just because there's a lot. Right, so these are all of the modes that we are in. We're going to start in the action select mode. And then if we select attack, we'll go into the enemy select mode, and then we'll select an enemy, and then we'll go into member attack mode, and then the turn will end, we'll go to the next member, and so on until we get to the enemies. Then the enemies will be in enemy attack mode while they make their decisions and do their attacks, and then we'll go back to our mode. So I'm also going to make by the way, I'm going to do this instead of using buttons and layouts and things. Perfectly fine, we can use those, but I'm also going to just use the arrow presses to navigate around the menu. Ah, geez. Okay. So I'm going to make a bunch of key press functions, and then I'll make a single key press handler. So just go. this code base is getting quite large. We'll just go right down to the bottom of the class and make those key press handlers. Okay, so see that I've got sort of a hub and spoke pattern going on here, where we have a key press handler, and then that will sort of throw out to a bunch of different functions. We could have this all within the same function with a bunch of nested if-elif, but that gets messy. And similarly, inside this handle key press, we could have a bunch of if-elif to throw out here, but that gets a little messy as well. So I'm going to use function references to call the appropriate handler. We'll go up to the initializer and create a dictionary. Okay, there we have it. So we can access into this based on the current mode, and it will return the appropriate function to handle that key press. So then at the hub, we can simply access into that. So we can say, okay, let's call our key press handlers, access into that based on our mode. And that's a function, so we'll call that function, with our event. Okay, so let's have a look at this. The action select. So I'm going to have to actually put a bunch of other things in the initializer. Okay, so this bears a bit of explaining. This self actions is a list of actions that will be used for selecting as well as display by the view classes. The difference here between a current member and a selected member. So the current member is the member whose turn it currently is, who is acting, and the selected member is if we want to do something like cast a healing spell, we'll select one of our own party members to perform that on. Similarly, if we want to attack, we'll select an enemy of the party, the enemy party. That's this selected enemy, will be selected for attack. But when it's the enemy's turn to attack, they'll have a current enemy. So there's just a slight difference there. And also this T parameter is being used for animating some things like the attacks. Okay, so that's fine. Now I'll just head down to... Actually, we won't worry about handling the key press just yet. I will go to the controller and call the key press event, just why not? Where are we? So I'll go if event type Okay, so later on when I add that logic in, it will be handling that. But at the moment, let's go to the view class and check that we're rendering this properly. Now, I am going to, just looking through here, So again, like, we could do this with stacks. I'm going to actually get rid of it at this point. And the same with, what else we have? We have the map view, that's fine. I'm going to get rid of the button as well. Right, so we'll find that as the combat model gets larger and larger, there's actually more information that needs to be sent to the renderer in order to render the scene. As a matter of fact, we start to send so much information that we get, there's one thing, it's fine, we can do it, but I really dislike it, and that's when a function has like 10 or 20 different parameters. That's messy. So instead of that, I'm going to simply send the whole game logic instance to the renderer. So I'll call this environment, and that will be an instance of the game logic. And then if we go back, you know, so it's a whole lot of back and forth. So I guess the way I'd say this is if we just have a few simple parameters, we can just pass them through. We could even wrap them up in a dictionary. That's a good way of parceling things together. But if things are just getting too big, then it's also okay to pass an instance. Okay. Just double checking everything. Right. So then we'll go to the renderer. The map view, I mean. There we go, and give it that environment parameter. Okay, cool. So this is all fine for now. I'm going to go ahead and add an extra class to render the action panel where the various actions, spells, attacks, and everything will be displayed. Okay, so there we have the initializer. Hopefully nothing here looks unfamiliar. Now, next we have the render function, and I'm going to make it so that this panel renders a general list. So it takes a list of strings, and each of those will be a different item, popping down to a new line each time. And it will also take the index of the currently selected item. So as it loops through, if any of those match, it will highlight the background of that item, make it a little clearer. So what we'll be able to do is we'll be able to use this for the menu actions, but then later on, in later stages, when we pop into spells and items, we'll be able to reuse this to render those as well. I just like to go through and fill in the parameter names. It helps. Okay, so as you can see, we go ahead, we render everything, and then we move the cursor down by 16 pixels. The cursor is a rectangle which tracks where the items should go. Now, because we're moving the cursor down by 16 pixels, we should probably check that the size of the font is 16 pixels. And I'm also going to change the text color to black. And that's fine because the text panel color is background highlight. And anyway, I'm going to be using the button active and inactive colors, which are, yeah, anyway, that's fine. Except, okay, so this is starting to get into spaghetti code. And the reason for that, it's just because I'm reusing colors in a non-logical way. I should probably rewrite my color system, my palette system, but that's fine. I'm not too worried about that, so long as it's visible. Okay. Okay, let's just give it a shot. See how it looks. Oh, of course, what am I thinking? This isn't going to display the text. It's just going to display the mode, because the map, because we need to create the layouts. So I'm going to call this okay. So we're creating that panel, and then we'll go down and render here. What I'm going to do is say okay, so right, I'm going to have to make a few functions, but they're pretty simple. We don't even need them, but I'll make them. So if we are in action select mode, then go ahead and render that panel. Cool. So I'll just quickly go over and finish that up. Must have forgotten to make a variable there. So the mode should be, if we go to, I guess we'll go to reset state. We'll say self mode is action select. There we go. Okay, cool. So we'll just go to the main, give that a shot. Okay, okay. Maybe it's calling them different things. Let's just get rid of the named keywords here. The thing is, I've declared this as a font, like a Pygame font. However, it's actually a true type font, which is a variant on the standard Pygame font. And so some of the function signatures might be slightly different, which is why even though this apparently just returns a surface, I'm still selecting the first element of it. And over here we can see in the signature, this should be called color. And I called it color, but then it complained. So it might just have a slightly different name. That's fine. It's probably like fill or background or something. There we go. So at the moment, we have our party and the enemy party, and we have our menu, and currently we're on attack. So what I'm going to do next is I'm going to add the key press handlers so that I can go back and forwards through this menu. Okay, so luckily I set this up already in the controller so that the appropriate key press handler is being clicked. So we just need to jump into this action select and start working there. Okay, so this is for scrolling through the menu. I have here the idea that, well, if we press down or we press right, those are both sort of progressing through the menu. So we modify the number and then we take its modulus under the number of actions available. This makes sure that we always get a number between 0 and 2. We can, of course, give that a shot. And we go down and it cycles through. We go right, it cycles through, up, left, it's doing what we expect. So the next thing is I'm going to say either space or enter are going to be the accept buttons. And I'm just going to do this for attack mode. I'm not going to do it for spell or item. But then things get a little bit different because it may, it's not something we've covered at the moment, but we'll get to it in a second. Let's say that we attack one of the monsters, attack the first monster and kill them. Well, then next time we go to select something to attack, we don't want to select the dead monster. There is a way to get around this, and that's simply to delete the monster from the list. But there are other ways to get around it. And there's a reason that we might want to not delete the item from the list when it dies, and that is when we go back into adventure mode, we don't want to delete our party members. We want them to still be around. And again, there are other ways to check it. For instance, what we could do is in adventure mode, when we go into combat mode, write the data to a file to read into combat mode, then set the HP for all of our party members to 0, and then when we go back into adventure mode, load the HP from the current party members in combat mode, meaning that if one of the party members gets eliminated, gets knocked out, the HP is they still exist, but their HP is 0 in adventure mode. But then we get into other things like, do they have status modifiers? And it's a little messy. So this is just the solution, one solution out of many that I picked. Anyway, I am getting far ahead of myself, but it is important to think about these things. Okay, so here, based on which mode the game is in, sorry, no, not that, based on which action is currently selected, we'll pop into a bunch of different things. Now, later on, when these actually become, I mean, this isn't too bad. If these branches of the if-elif got bigger, then we might want to do a similar thing to what we did here, where we have a hub and spoke. We have a dictionary of callbacks to call back to, and then we access into that dictionary, but this is fine. So first valid member, let's have a look at that function. So I'll just go up here, we'll go, okay. So basically what this will do is, we should also have Yeah. So we take the leader of a group and we basically look through that linked list and return the first one which has non-zero health. But it's a little trickier because we don't want to return the character which has non-zero health. We want to return their position within the list. And there's a bunch of different ways to do this, but I'm going to write two really helpful functions in the character class, which we might use them here, we might use them later, but they will be useful. And those are the size and accessing members. Okay, right, so for size, what we'll do is simply traverse through the linked list, increment a counter, and then return the counter. Okay, that's good. Then for @ pretty similar. We'll have a counter, we'll loop through, keep incrementing the counter, and then when that counter matches the position, actually no, we'll increment a certain number of steps, the position number of steps, and then return the member, if that makes sense. So again, we start with the self and then set the counter to I, and then our condition here will be while I is less than the position. Go to the next member, increment the counter, and then finally return the member that we're on after incrementing that certain number of times. Okay, so those will definitely be helpful. We can leave those and go down to first valid member. Okay, cool. So we look through the linked list. The moment we see a member with HP above 0, we return them. Oh, we return the position, sorry. Okay, so that's all well and good. Now what I want to do is we'll make another function, and this is sort of coming together. I'll make another function called next valid member. Okay, so we take basically a member of a group, we look through the group, starting at this current position, searching in this direction, could be backwards or forwards, and we return the position of the first one which matches. Now, we might be looking at this and saying, wait a second, what if, for instance, all of the enemies have been destroyed and I'm in attack mode and I'm ready to attack an enemy? Well, it's a precondition of this function that there is a valid member. What a precondition means is it's a check which is assumed to be true, and we have faith and say there are other parts of the code which are going to make sure that we never get into this state, basically. So anyway, what we'll do is we'll say, okay, next member equals, we'll go increment in the search direction and take the modulus under the take the modulus under the number in the group. So see, we're using this size method now that we defined earlier. Okay, so then we go, okay, if the leader of, the member of the party at that next member position, if they have 0 HP, then recursively get the next member. But otherwise, simply... Okay. So for our little demo, well, yeah, no, we still need this for item select and if we want to cast healing spells on ourselves. Okay, so we have the first valid member, the next valid member. Let's go ahead and use those functions. So we have action select. I'm going to grab these ones. Actually, I'm going to grab all of this. And I'll go to enemy select. Okay, so we hit down. Let's say we want that to be the next enemy. Okay, so I'm just going to do this as well. When we go into enemy select, let's say, oh no, it's okay. I am double tracking, I'm messing myself up. We are already selecting the first valid member. Okay, good. Right, so now let's say we hit up. Well, then we'll get the next valid member in the backwards direction from our position. Okay, now let's say, this is actually very simple. Let's say we hit enter. Then we'll change our mode into member attack mode, and we'll reset the animation by setting time to 0. Okay, fair enough. Well then, what happens when we're in attack mode? Well, if we're in attack mode, then the show is pretty much going to run itself, but I'm just going to make a bunch of other helper functions which will be useful. Okay, so this next turn function is going to process the logic of what do we do when the turn ends. If we're in our party, we'll go to the next party member, but what happens if we run out of party members? And so on. Okay, cool. So this bit here is saying, well, if we've reached the end of the list, if the current enemy that we're on matches to the number of enemies in the party, then we'll go over to the player's turn. We'll reset any selected or current state. We will select set the first valid, party member, and then set the mode to action select. Okay, cool. Otherwise, we'll progress within the enemy turn. So we'll say current enemy, go to the next one. And then, this is super important, we need to check if the next enemy that we've selected is valid. So we'll say yeah, so if we've got no health, then recursively go to the next turn. Okay, so otherwise we pretty much do the same thing but just reverse the roles. Now it's worth noting that when we go to the next enemy turn, we will always be in enemy attack mode. That's just, we treat the enemy's decisions like a black box. They do their own thing. But will probably be in member attack mode or member spell mode or something over here. So when we go to the next turn, we need to reset it to action select. And by the way, there's another bit here. If we're in enemy select mode and we hit escape, then we want to go back into action select mode. Okay, cool. Apologies about the background noise if that's coming through. I don't know what they're doing out there. Anyway. Right, so we've got the next turn logic happening. Now I'm going to make two other functions. Okay, so these are both traversing through the lists, and the moment they see something which is alive, it changes the conditions. Alrighty. So then I want to make an update function. Okay, so this is just checking, are we attacking? And this self T check is just making sure we don't attack twice. So time is going to run from 0 to 60 for an attack, so it lasts 1 second. Yeah. Okay, cool. Just double checking this. So also, if it's the enemy's turn, they are going to need to select a target, but we only want to select from among the party members who have some health, which is what this loop is doing. And then we randomly choose from among there, access that member, and damage them. Cool. So that's the attack. What am I thinking? That's the attack logic. Now we'll have the regular turn progression, which is, it's pretty straightforward. We'll just increment time and possibly call the next turn function. Okay, so what we could do, and I'll actually add this in future, is we'll also add logic down here to check whether the game has been won or lost and return some sort of flag from the update function. But yeah, no, I'm happy with that. We can close that down, go to the controller and update the game context. Yeah. Okay, that should be fine. All right, so that is pretty much fingers crossed, that's all of the model stuff done. Now I'm going to focus more on the view, getting that view working. So I'll just pop over to combat view and yeah, panel's probably fine. Yeah, I'm going to split this render stuff into two separate functions, just because it's starting to get a bit big, and it'll definitely get big later on. Okay, so let's keep going here. So we probably, yeah, I remember now. We actually shouldn't include this rectangle X and Y, and the reason for that is by default coordinates are relative to the rectangles there within, so we can actually mess things up quite a lot if we include this rect X and Y. That's fine. I'm going to include a counter, which we will increment every time. And that counter will be useful for checking against the current enemy, selected enemy, and all of that. Just checking through here. I'm going to make a variable called X displacement, and this is for instance, when an enemy is the current enemy, they'll be stepping forward to attack, so there will be an X displacement on them, and for all the other enemies, they'll just be in line, so they'll have no X displacement. So the way we express that is we go ahead and write that here. And then when the enemy is attacking, they will be shaking around a little bit. So I'm gonna add some comments as well. It makes it more readable. So we'll say, is the enemy alive? Okay. Okay, so this is the check for the current enemy. So I'll say if I is equal to, and I'm going to be lazy and just access the variables directly. Okay, so if you are the current enemy, step forward, step to the right by 64 pixels. Okay, so I'm just going to quickly pop back to the config and import the math library so that I can use cos, because I want, where are we? I want the displacement to have an oscillation in it. So multiply it by cos. Actually, what am I even thinking? This should be sine, shouldn't it? Because sine starts at 0. Okay. Okay, so what's happening here is I want a full period of oscillation to last for 15 steps, 15 frames. So I take the frame number, divide it by 15, that gives me something between 0 and 1, and then scale it up to a full oscillation, a full period of 2 pi. This is a standard formula. And yeah, we can see that we're going between 0 and 15 frames. The way I want this to work is 0 to 15 frames is the enemy attacking, and then 15 to 45 frames is the delay, and then 45 frames to 60 frames is the selected target getting knocked back. So that is the action of attacking. The other action I'm going to add is being knocked back. And this happens in member attack mode when we are the selected enemy, and the frame is between 45. So we will have to subtract 45 to get this parameter between 0 and 15, but otherwise it's going to have a period of 15, and that's fine. Now, in this part here, we are swinging forwards because we're attacking. In the other part, we're being knocked back, so we'll subtract that. Okay, so yes, we're drawing the enemy, and then we'll draw the health bar. Actually, we probably don't even need these checks. Let's just draw the health bar always. That hasn't been defined. Okay, so we'll just go up the top, make a new color. There we go. Okay, nice red color. We'll use that in the health bar. Okay, good. So let's test that. All right, we can see we have the enemies, they have their health bars. We can go space and just attack, and they get knocked back. Attack again, they get killed, then the enemies attack. Yeah, that looks fine. Okay, let's duplicate that code basically and use it for the player. Okay, so because we're on the other side of the map, stepping forwards means decreasing X. Forgot to set the counter, we'll just set that to 0 and keep going through. Okay, so similarly, we're just reversing all the directions. So when we step forwards, that's subtracting. When we're knocked backwards, that's now adding. Okay, fingers crossed, let's try that. Okay, so now you can see we have the full party, everyone has their health bars, and the warrior, just from the text file, already started with a bit less health. So we go attack. Oh, I must have forgotten about that. Okay, well, let's just attack something else, then they attack. Something seems a little strange. Why did they both shake? Okay, let's investigate that. This bit here. We should not be setting I to 0 here. We should be setting it up above. of. And there's something else that I missed. See, when we were selecting enemies, it wasn't selecting them. So let's go here. Also draw sprite, not spree. Okay, and we'll do the same thing for the players. So yeah, as you can see, we're just filling in a white color in a rectangle, and then we're drawing over that with the sprite. So the end effect is we basically get a border of 2 pixels around each side of the sprite. Yeah, okay, cool. So now let's give that another go. Yep, we can see all the parties. We are stepping forward to attack. We can choose which one we're going to attack. So down works, up works, left and right. Okay, let's attack this guy. Killed it, good. Let's attack this one, killed it. Okay, now the enemy attacks, we get damaged. We attack the enemy, and we're done. We'll add those extra checks in later. So there we have it. I know this was a bit of a code-heavy session, but we got there in the end. And you can see why I just did attacking, because there's a lot. But we're almost there, right? I mean, once we get spells and items working, they won't be too tricky. There'll be a variation. As a matter of fact, when we go onto those other modes, we might start to see ways to simplify the rest of this, I guess. And then it's actually, once we get the game working, we can add in images, we can add in sound and music and everything, and actually get it looking pretty cool. Okay, so good session, and I'll see you again in the next one. Bye. Okay, so just to start with, I'm going to do a few refactors. If we go to the model, note that down here we've got this current member, current enemy, selected member, selected enemy. This is a little bit redundant because we also have encoded the state that our model is in. So we should be able to work out, if we just make a single variable, call it like current character, we should be able to work out from context what that actually is. So let's go ahead and change this. Make this current character. And then over here we'll make this selected character. It actually doesn't matter what we set these to. Let's just do that. Okay. Then what I can do is just go down to, if we look at reset state, that puts us into the action select mode. Okay, fair enough. Then if we look down at this load from file, after we load everything, then I'll set the current character. So we say, hey, based on the party leader, what is the first valid member? And that sets it so that current character is always pointing, always starts off pointing at a good party member. Okay, so then you can skip through this bit if you want, but basically what I'm going to do is I'm going to go through everywhere, current enemy, current party member, whatever I called it, change that all to current character, and same for selected. Okay, so that was a lot of fun. What we'll also need to do is go to the view class and update that. Same stuff there, unfortunately. Yeah, it just is what it is. Okay. Wait a second. We should also check selected. Okay, look, good. Good idea just to run this and check that it's still working. Yep, that looks fine. We do have a problem though. So see that it is currently the green player's turn, but this loop doesn't have an extra check in there. So it's saying, hey, wait a second. When we draw the monsters, this is monster number 0 and character number 0 is current. So we just need to add an extra check there. So we can go to the view and scroll through this. Okay, so what we have is we want to check mode. So yeah, just only do this if we are in enemy attack mode. And then if we go down to rendering the player, similarly, we will just say, hey, are we not in enemy attack mode? Okay, fair enough. So let's give that a go. Yep, so see now it's only the green player who's coming forward. We can attack this one here. And yeah, now that works fine. So there's another thing before I go on to the spells and items, which will be the main topic, is I'm just going to break apart that rendering code a little bit more. Just for aesthetics. So there are 2 stages we can break out of this render enemies function. Firstly, the stage of calculating the X displacement, and then the stage of drawing the sprite. So let's go in here, let's go okay, cool. So we can go down and grab all of this stuff. And we can save that, so we can go run that function. And yeah, that reduces the line count of the code. Okay, just checking through that again. I think that's fine. Yeah, hey, we'll find out if it's not. Okay, so then we can make another version for the player. Cool, so there we have it. Nothing too unfamiliar, we're just copy pasting the code, breaking it out into separate functions. Unfortunately, they're not super reusable. I tried making a reusable version that I could use for both functions, but it was just getting too annoying with the various flags and things that I had to set. Might as well just make 2 functions. But a function which is reusable is a function which will draw the sprite. So as we can see here, we have 2 stages, the sprite and the health bar. And I'm also going to make a magic bar. But let's grab this. Okay, cool. Now, in order to draw the magic bar, I'm just going to define a blue color. And I'll use that down here. That's just 00255. Okay. All right, so I'm just going to shift everything up a little bit. So I'll shift the health bar up by 8 pixels. And so down here, the magic bar will be that'll be just fine. Okay, so I have magic points. And I should also check this, right? Because if the character has no max magic points, then we'll be dividing by 0. So we'll say that looks fine. Alrighty, so then we can use that function. So we can just close that down, go down to this render part, and then where were we again? In here. So we'll say okay, it's looking good. Close that down, and then to the players. So we get the X displacement, we do all this stuff, and yeah, cool. Okay, let's give that a shot, see how that looks. There we have it, so we can see the health bars and the magic bars for everything. It's a bit of an optical illusion. That looks like it has alpha, but if you get close, no, it doesn't. It's black. Okay. Alrighty, so where were we? Alright, so yeah, let's get on into it. We'll just go top down through combat model. The goal is to add spells and items, and I'm going to make an improved system for handling behaviors and things. So just checking here, all of this looks good so far. Damage generators, yep, that's fine. We have some item types which we've defined, and that's fine. But I'm also going to define a dictionary of item names so that these can be displayed. Weird word. I believe it's pronounced draft, but every time I see it, I just think magic draft. Anyway, okay, so we have a bunch of modes, and I'm just checking through these again. Action select, enemy select, yes. Spell select, yep, okay. Item select, member attack. Item used, so I'm actually not going to include that. Member select, yeah, the rest of that is fine. Now the reason I'm not going to have item use is I'm going to define some modes up here, but then down below I'm going to define a bunch of actions. The benefit of having sort of a mode constant and an action constant is that we don't need to track so much in the mode. So what are we doing here? Let's say this is, we're in enemy select mode, but then after we selected an enemy, how do we know what to do with it? it would be better if we had a separate variable. So we have, okay, we're in enemy select mode, and the action we're going to perform once we've selected the enemy is we're going to attack them, or we're going to cast harm on them, or you know, we're selecting a party member, and after we select the party member, the action we're going to perform is we're going to heal them, or we're going to give them a magic potion. It just makes things easier. So I'm happy with that. We can close that down and go to the game logic. And then if we go into here, yeah, we have the key press handlers. That is fine. We have the actions. And then I'm going to define a few more. So for the items, I'm going to make that an empty list. And the reason for that is the inventory sort of comes and goes. So when we say use item, we then want to search through the inventory and dynamically populate that list. Okay. But otherwise, again, the spells, I'm keeping it simple at the moment. We'll say those are fixed. And we'll have a variable called next action as well, and that will keep track of the intent of the player, basically. So when we go into a select mode, we'll keep track of what we're going to do once we've selected. Okay, reset state, just check that. Yeah, that's fine. Load from file, yes, we load everything and then we grab the first character that we can. That's fine. This is all okay. Load inventory data, yeah, that's fine. These things, okay. First member, handle key press, yeah, that's fine. But then we get to these bits here. So let's check into that a little bit. Okay, so this up-down stuff, that's fine. We're just changing our actions. Now, if we hit space, so we want to go into attack mode. So we'll go into enemy select mode, and then we'll register that our next action is going to be the attack action. Okay. Then if we go into spell select, this is fine. I guess we can also set our current action to 0 so that we start, you know, with the first spell and go from there. But there's another thing we want to do. Not everyone can cast a spell, so we want to say yeah, just a really quick check is just to say, hey, do they have any magic points? Okay. Now, if we click space and we are on item select, then at this point we need to build our inventory. So we'll just reset it in case it has been built already. Okay, so when we call items on a dictionary, that returns a bunch of tuples in key value pairs. So the keys are the type of items, the values associated to that are the quantity of items. Okay. Now we want to just have the items which are usable. So we can say just anything except bones. Now remember that these need to be lists of strings, so they're renderable. So we'll just do an F string here, where we'll have, if we go look up the item name, and then display the quantity. And there we have it. So again, we build the items list, then we go into select mode, and by default start it at the first item. So those are all the possibilities if we are in action select and we go, yes, do this action. Okay, so we'll go down to enemy select. So if we're in enemy select and we go up or down, yeah, sure, we cycle through. But then this becomes important when we hit space. Well, actually, just double check my notes. It doesn't become important because we can use the same logic. Let's just say that member attack mode just stands for the member doing something. So that's fine. Okay, it's this, this spell select and all of that. So just go to action select and grab that code again. Just grab a little from here, a little from there. Okay, so yeah, if we go up or down, we'll cycle through, but that's based on the number of spells that we have in our arsenal. Then if we hit space, we want to check which spell we're on. And at the moment, it's a very simple system. It's either harm or that's it. So we just have an if else. Harm or heal. So if we hit, what are we doing here? Yeah, if we enter into the harm spell, then yeah, we will select an enemy, but then the action becomes harm spell, and yeah, that's fine. Otherwise, we are in heal mode. In which case we select one of our friends for the heal spell. Good. All right. There's a lot of talking to myself. That's the life of a game developer, talking to yourself. Okay, so next we have item and member. So, yep, these should all pretty much be similar. I mean, member select should be pretty similar to enemy select. So we can just grab that, put that in. And then, yeah, let's look at these in more detail. So item select, again, I guess it's a precondition to this that everything has been set up properly. Okay, so what we want to do is we want to access self items based on the current action, but remember those have been baked in as F strings with like item name or item type, whatever, and then colon and then space and the quantity. So what we can do is partition that. Yeah, so if it's a health potion, then we use it on one of our friends. And then the only other option is the magic potion. Not member attack. I didn't make that mistake earlier, did I? Yes, I did. Let me just quickly check. Okay, I guess the rest is fine. As always, we'll find out. So, yeah, so in all of these cases, you know, we will select one of our party members and use a various potion on them. Yeah, the rest of this is fine. We can clear that. Then finally, we have member select. And this is pretty straightforward. We just search through the the party leader linked list. And then, yeah, when we select one of them, then yeah, we're attacking. And remember, attack is just shorthand for we're doing something. Like we've selected the actions, we are good to go. Yep, okay, good. Okay, so yeah, get mode, get actions, that's all fine. Alrighty, next turn. So this is one that we're going to have to break out into a few pieces. It gets a little big. Actually, no, that one's fine. It is a little big, but it's probably fine. It's not going to get worse. Okay, has won, has lost. It's these update functions that need to get modified. Okay, so here we can grab this code, throw it into a function called member_act, and go for it. I will just add here. See here, this is the part that we should only do if the action is the attack action. And yeah, this is one of those cases where we could break it into other functions, but I'll just leave it here for now. Okay, great. So the ironically, the enemy act function is the smallest because it doesn't need to change. And yeah, the rest of this is fine. So we'll return to that member act, and we just need to make a whole bunch of different branches. Okay, so I'll just grab the party member, declare them up the top. Yeah, so for the first two, we're targeting enemies. For the bottom three, we're targeting friendlies. Good. So for these two cases, we take action, we heal, we do damage, whatever, and we also reduce our magic points. And then down below, when we use items, what we want to do is decrease the quantity, potentially remove it from the inventory. Yeah, cool. So we're just removing items when they run out of quantity so that we don't select them again. Why would we? Okay, so I think that's fine. We can close that up. It's quite a big function. We should really be breaking that into little pieces, but it's acceptable, I guess, unless it gets any more complicated, in which case we definitely should break it up. But I think this is about as complicated as it gets. We are onto the point now where we'll start to put the pieces together and flesh it out. The basic system is done. So there's one last thing, and that is updating the panel so that it displays the lists. So what I'm going to do is I'm going to say, we'll go Oops, not self. What am I thinking? Now, when I say item list here, I mean literally like a list of items to display on the screen. There's nothing to do with the inventory or anything. So, yep. I'm just going to grab this and pop it outside so we're always rendering no matter what. It's just a case of what text we add on top of that. Okay, cool. So we select which list of strings we want to write out onto the panel, and yeah. And what's this complaining about? Probably the tabbing. There we go. All right, let's give that a shot. Okay, cool. So the mage is ready to go. Now I guess the first thing we'll do is cast a spell. Let's go harm, and it's like, okay, who do you want to target? Let's say, oh, that's a mistake. Let's go back. Okay. Let's heal ourselves first of all. Okay. Oh, did you see that? That's pretty important. Let's try this again. Spell, nothing can happen. Let's go give a magic drogged to the mage, and watch the purple character. The purple character. Uh-oh. That's not good. Huh. I'll have to look at that in a second. There should be a quick fix to that. It's not good, but early exit. There's probably something dodgy that I should double check. Should definitely double check as a matter of fact, but let's leave that for now. What I want to look at is when I use an item, the other enemy vibrates, which isn't good. But actually, there's a quick fix to that. I think. There we go. I think that's fine. So these are just the cases where you would actually, the cases where you would actually be knocked back by an attack. It's a little bit dodgy, but it's currently getting the job done, which means I'm going to have to go in with Scotch tape, intellectual Scotch tape as I call it, and double check that. But right, so back to the other problem. See if I can find where I'm messing that up. Strange. Well, I mean, one thing we can always do is just keep we can always just keep trying this, seeing if we can replicate the error. So what will we do? Let's try healing spell on ourself. Now if we watch the purple pinky player, they do not move. Oh. Okay, that's not great. Okay, well, okay, let's go item, magic draft. Huh. I may have messed up my conditions there because this is a lot of fun. So, oh yeah, look, the condition's on the wrong section. Okay, give that a go. Alrighty, so we'll cast heal on ourselves. Yep, enemy doesn't move, that's good. We'll give a magic draft to ourselves. Yep, that's fine. But why are we now not moving? Back to the drawing board. Oh. How did I mess that up? This should be the enemy leader. No wonder that was... Yeah, okay. Well, this should still be fine, this none test, because now it should never be none, so that's fine. Just double checking everything. Okay. Let's see how that goes. Okay, so we'll cast heal on ourselves. Then we'll give a magic draft. Now, watch when the enemies attack. We should be knocking around as well. Okay, enemy attacks. Oh. Okay. What's wrong? Okay. Okay. So it says selected character is -1. What's going on there? Oh, this is selected member. It should be selected character. The refactoring from the start came back to get me. Okay, so let's check again for selected member. It doesn't show up. Let's select, check for selected enemy. Doesn't show up. This is actually annoying me a little bit. Current enemy doesn't show up. Current member doesn't show up. Okay, good. Good. Okay. Fingers crossed. So we go. Alrighty. Cast a heal spell on ourselves. It works. And then give a magic draft to ourselves. Then they attack. And the animations are working good. Good. Awesome. Cool. So that'll do it for this one. That was enough. In the next session, what I want to do is set it up so that I can walk around the map and enter into a combat scenario, and I can also, if I win the scenario, go back to the map. Alrighty. Have fun, have a good one, and yeah, that'll be it. Bye. Okay, welcome to the next stage. This is the point at which the program is really going to become Turing complete, so to speak. We're going to bring it all together. Now, just a quick note here. At this stage, we will find that we are duplicating some behavior. We could go and refactor it. That would be a good idea. Make a common file which has subclasses and superclasses and extensions. For instance, have a game logic superclass with common behavior and extend that. And actually, I went to go do that, but then I found that, yeah, we can do it. It takes a lot of time, and there might be some payoff, but maybe not in this video. You don't want to watch me retype everything. It's not fun. I wasn't having fun. So that's to say that this is going to be maybe a little bit janky, maybe not 100% the perfect way to do it, but it works. And it's good enough for this. It's on the verge of needing some work. As I say, if we do anything more to it, we'll need to maybe break it apart. But anyway, here's what we're going to do. First of all, I'm going to have a few refactors. The combat view, I noticed I was passing around environment as a parameter, even though that's a static class. So we should 100% know what environment is and not need to pass it in as a parameter. Then the character class is actually going to be used by both modes, adventure mode and combat mode, because when we get out of a combat, we need to know how much health our characters have. And when we go into a combat, we need to know how much health our characters have. So I'm going to make that into a common file, its own thing, that we can interact with. Then we'll get into it. So I'm going to set it up so that the adventure model, as well as loading in the terrain and everything, can also load in information about the party, so it can update after battles. I'm going to set it up so that as we walk around, we will randomly generate a battle scenario, and of course, we don't need to save the map state. I got rid of that. The static class is persistent, so we don't need to. It's a good idea not to save and load it. As a matter of fact, it's easier. We are going to need to, once we've generated that battle data, write that out to a file, which the battle mode will then read at its beginning. Then after combat ends, we're going to need to save the new party data to a file, which the adventure model will read. So things are starting to come together. Then finally, the controller is going to need to control everything. So I'm going to set it up so that all of the update functions return some sort of code, an integer, indicating what to do next. And I'm going to make some transition functions for the app. And then hopefully, fingers crossed, we're going to be set up, we're going to be at a stage where we can start bringing in graphics. Okay, so first of all, this is nice and straightforward. Combat view, game context. So we'll go to combat view, and I'm just going to make a variable called environment, and we know what this is. This is, we go to combat model, get the game context, that's our environment. So then, anytime environment is being passed in as a parameter, we don't need it because it's a static class. We have a reference to it all the time. So here we go, we're querying that. Here we go to render the enemies. We don't need to pass in environment as a parameter that is already known at runtime. So then again, horizontal displacement does not need to know environment. Well, you know what I mean. It doesn't need to be a parameter. Okay, so all of this is now going to work just fine. Okay, and similarly, we do not need this environment parameter. Just clicking through, checking it. Oops, we don't need that. And then down below, we're getting horizontal displacement, but we don't need that parameter. Same thing here. So basically, anytime environment is being taken as a parameter or passed to another function as a parameter, we don't need that. The less parameters we have in our function, the simpler it's going to turn out. Okay, so it's a good idea just to double check that by running it. Because we need to go to controller. So in controller, we are still passing in a game context. We don't need it. We don't need it. The shot. Okay, that's running. Attack. It seems to. Yeah, that seems to work fine. I'm happy with that. Okay. So that part is done. Now, get the character into an independent file. So what we could do is we could make a file, call it character.py, but we'll start to notice that because both of the models are now saving to and loading from files, it would be advantageous to have a common definition of some of the constants. So what we can do is I'll just call this model.py, and this will hold everything which is common. Yeah, everything which is common to both modules. So we'll grab that, and then if we go to combat model, so we don't need that anymore. Again, remember, I'm using future annotations for the forward references here. But that's fine because we're going to grab this whole class. Down a little bit. Grab the whole class. Put it into model. And don't forget to import that. And just double check. Everywhere we see character, we'll send that in model character. Okay, I think that's fine. Cross my fingers because that's a lot of code. Okay, then we'll go to combat view, check that that's working fine. Is it? Is it though? Yeah, okay, that's probably fine. Right, so there are some other things which are going to need to be shared though, because we're loading in. Yeah, because we're loading in some state from files, in both cases, saving and loading, we're going to need to put these constants into the common state. And I'm going to go ahead and make a few extra things as well. Okay, so I'm just making this so that when I go to write information to a file, I'll have a quick lookup to get the official names that I should be writing to the file. I'm also going to define the various return actions as well. There we go. Very verbose here. Return action can continue. Return action, return to adventure. Don't say that. don't say that one fast. Okay, that's fine. We got stuff. But here we have some issues. It's probably, I need to go model dot. So what do we have down here? Yeah. So basically anywhere this is erroring out, it's a constant that I've thrown into another file. So I'll just preface that with the model module and it will find that constant. Yeah, there we have it. Okay, good. It's a good idea just to give this a shot. Okay, what have we missed? Combat model soldier in... That'd have to be in combat view. So why was that not complaining? I'll never know. Yeah, so as you can see, these modes and actions and everything, they're fine. It's the enemy types that I'm really after. Okay, I think that's fine. Give that a shot. Okay, yep, that is working. Excellent. All right, so we've got that independent file done. Right, load party data. Well, we'll need some party data, so we'll just go down to the forest.txt and I'm just going to paste in this, yeah, all of this, the inventory, the members, everything except the enemies. I'll put this down the bottom. So as well as the map and knowing where our avatar is and the NPCs, we'll also need to know, yeah, where the information about our party. So then what we'll need is we'll need to load them in. So we'll just go to combat model. And here it says load from file. So I'm just going to grab these bits, identifying the headers. So we'll just go, yeah, we'll just go down to the adventure models, load from file. We'll add that logic in there, and then we can literally just copy paste the, copy paste the files, the functions. So again, this is a point where we could probably just, well, it wouldn't be so useful, I guess. I mean, we could make external. We could make external function libraries, but this is just one of the points where, you know, we're close to deadline. We're just going to bite the bullet and go for it in this particular area. Now it says we need the model, so we'll go ahead and import that. And then it's going to say, yeah, so we have this self party leader, but I mean, we don't really have that yet. So what I'll do is I'll make which just declares a party leader. So just reset that to none and make an inventory as well. Set it to a blank dictionary. Okay, now the reason that I'm keeping this separate as a separate routine and not inside reset state is that reset state will actually clear the whole map, and I want to keep the whole map around. I want to keep the NPCs in their place. I want to keep the ground in its place and everything. But at some points, I might want to just reset the party because I'm going to load it in from another file. Okay. So where was I? Load party data. I guess there are ways we can test that, but let's just run it and check there's no error. There's no error, that's fine. Check that that's running in adventure mode with no errors. Yeah, that's fine. Okay. Happy with... Oh, stop. The NPC stopped for a second and I thought the computer froze. My computer's been randomly freezing. I don't know what's up with that. Okay, that is fine. Okay, load party data. Okay, randomly generate battle. So, when the player is on radiated ground and they walk a certain amount, there's some probability that a battle event will occur. So I'm going to go to the model and work on the walking thing to start with. Oh, sorry, it's not the character, it's not the model, that's fine. It is the player. Okay, so this stepped a bit variable will be set to true when we want a battle to be tested to see if one should occur. Reset last position is basically just going to remember the current position and say, hey, this is the last point that I was at. And yeah, about 32 pixels is how far we want to step before we test. Okay, so let's go. There we go. Nice and straightforward. We're just taking a snapshot of the last position we were at. There we go. Okay. Remember to spell correctly. When you're up at 2 a.m., it gets a little tricky. Okay, so here we go ahead and change our position. Now we want to say, hey, how far have we moved compared to our last position? So I'm going to reset this dx variable. I'm going to set it to the absolute difference of currently our x position of our rectangle, the top left corner, minus x position which was stored previously. And I'll do the same thing for dy. And then we'll just get the sum of those and see if it's more than 32. So if you were to graph this, this would be taking a taxi cab distance metric. So basically it's just a quick way of measuring distance. It's accurate enough for these tests. Okay, cool. So we've got all that. Now let's go to let's go to the update function. Actually, the move function. Actually, no, that's fine. Yeah, change my mind. I'll go to the update. So I'll step this out. So we have, if we've stepped a bit, the next condition is basically, are we standing on radiated ground? And I'll make this function in a second. It will take a sprite to check and a group to check against. And if both of those are true, then we'll go ahead, we'll go ahead and generate a battle. One thing we'll do is reset the stepping position, because I found when I was testing this that I would walk a bit, I would get into a battle, I'd win the battle, then I'd go back and immediately enter into another battle because I was forgetting to reset. And the game was thinking, hey, you've stepped 48 pixels all the time. So it's important no matter what happens, even if this roll fails, because if this roll fails but I'm not resetting my position, then I walk another pixel and immediately trigger a battle. It's weird. So we'll have this. This will randomly generate a number between 0 and 1. And this will basically, this if statement will trigger with a 50% chance. Okay, so I haven't written this function yet, but it will randomly generate a whole list of strings, all of which are monster names, and then we can go ahead and pass that in, save the data, and then we'll go ahead and return. Actually, let's not do that just yet. We'll save that. All right, so what do we need? We need on ground. So we'll go ahead and define that. So there we have it. This is a pretty standard routine by this point. Right, so we've got that. The next stage is to generate the monsters. So again, remember this is randomly generating a list of monster names. Okay, so there we have it. As we can see, I have written rat twice, and the reason for that is that I want the rat to come up with a 2/3 probability, but it's not fixed. So yeah, we have the set that we're choosing from, the number of monsters, anything between 1 and 4, and we just loop through, randomly choose one, and just return that set. Okay. So far, so good. Then I want to save the battle data. Okay, so we'll go ahead and make these functions in a second, but yeah, we understand that this is always going to be called battledata.txt, open it in write mode, and then go ahead and write all these things. So at this point I can go ahead and just delete that file. Yeah, because we're about to randomly generate one. So what do we do? Let's go save monster data. Yeah, okay, good. So it's really important to remember to include the new line at the end, otherwise it'll all just pop out in the same line and the file loading functions won't deal so well with it. But yeah, there we have it. That's saving the monster data. Then we can go ahead and save the party data. So yeah, I'm not going through this in a super deep level of explanation because We've been through this a number of times, and hopefully you're getting comfortable with it. This one will be a bit of a nightmare though, just because there's a lot of lines. So anyway. Yeah, so here we're going to be doing a linked list traversal. Yeah, just not forgetting the trailing new line. Yeah, so as you can see here, it's just a lot. So we're just writing in all the various properties of each party member. Okay, so we have that. And finally, we're going to save the inventory data. And thankfully, this is quite a bit simpler. And that's it. So as you can see, we use the item descriptors to look up the appropriate item name. We could have done that up above with the member type as well. Would have been fine. We could have done something like that. So yeah, then we have that. We're saving the inventory data. Inventory, not infantry. Oh, I guess here we're saving inventory data. Ha ha ha. But yeah, okay, awesome. So let's try that. Give this a go and keep an eye on here. I want that battle data text to appear. So here I am, I'm walking. I'll just get into the green zone and walk, walk, walk. There we go. Okay, so I can close that down and check. Okay, so it's generated for me just a single battle with a rat, and this looks like what I expect. Okay, so let's test that. Let's go to the controller and enter combat. Yeah, it's a rat. Okay, we attack the rat. Rat dies, everyone is happy except for the rat. So yeah, we are randomly generating the battle and we are saving the battle data. I'm happy with that. Okay, now save the party data. No problem. We can just go... Yeah, let's go to adventure model and see here we have save party data. Okay. Nice function you got there. Shame if someone copy pasted it. Okay. Just double checking. There is actually more to it than this. So we have save party data, and then we'll also need to save the state of the inventory. We don't want to lose our items. Actually, it wouldn't even be that, would it? You'd be using the items. We don't want to, yeah. And then what I'm going to do is I'm going to make a wrapper for that, which calls everything. So see here we have save battle data. So I know this is a little dodgy. It should really be like save party data, but that function name is already used down here. So we'll just call it Save battle data. I know, it's not great. But we will call this, yeah, partydata.text. And that's it. That's all we need. So we've got that. And we can test it by, we'll just give this a shot. So there we are. Actually, let's not do that yet. Let's go to... okay, it's fine. I mean, it's pretty easy to test, but I'm just being a little lazy, so we'll leave that for now. Okay, updates return codes. Should be fair enough. So we'll go to adventure model. Go to the update, and now we'll return an integer. By default, we'll return the continue code, but if we get into a scrap, then we'll return the start battle code. Okay, cool. And then we'll go to the combat model. I really should do something, but anyway. Okay, so go right the way down to the bottom. And I'm going to say, okay, this should return an integer. Oh, whoops, wrong one. This one, update, should return an integer. Okay, so again, by default, this should return the continue. But over here we should test. So we'll say, okay. Okay, cool. So yep, hopefully that makes sense. And really important is we're doing these checks after we reach the end of an attack mode, because realistically, monsters and party members are only going to die after an attack. Yeah, not even after heal. Like, what happens? You heal yourself and then a monster dies? Doesn't make sense. So yeah. Okay. So we need to handle those. So I'll just go to the controller and I'll change these. So go up to the up here and import model, and then go right down to the adventure main loop. I'm going to change this. I'm going to call this return action. Set it to continue, and then my test for this while loop will be that it is set to continue. If we hit quit, then I'll set it to game end. And this is actually super important. It's actually super important that I include this test, because what I'm going to do is I'm going to call update and use that to set the return action. And so we go through, we do our thing, and then we come down to the end, go back up to the top, test that while condition again. However, if we hit escape at this point, we say, okay, we want to end the game. But then if we don't have this test, then we'll continue down, then we'll update, at which point this gets reset to continue. It's not so good. So it's really important to have that test, and I'll include that test right down. Okay, cool. So what do we have? Updates return codes. Yep. So now we just need to make transition functions. Okay. Good. So we'll go back to the controller and we'll test what this is. So if we get back to the end and this while loop exits, then return action has to have something other than continue. The program would end at this point, but we just want to check. We'll say if the return action is start battle, then we want to go we'll go transition into battle. Okay, fair enough. Then we'll go to this one and we'll go, okay. If we get to the end and everything's done and we're saying, hey, I want to go to an adventure, we'll go transition into adventure. Okay, now we just need to write these functions. So we'll go back up, and by the way, we will just start in main loop. Okay, so hopefully this should be nice and pretty. Should be good. Yeah, so we'll simply, reset the state, load this from the file, start up the main loop. Actually, I wonder if we even need that, because if I look down into the combat main loop, sort of loading again. It's maybe not the best idea. Let's get rid of that. Okay. Yeah. Okay, so that's fine. Then let's make the just double checking this. Yeah, we should probably yeah, I should change this. Okay, so this is just making sure when we click run, we load from the forest file, but we just do that once. We're not doing that every time the adventure loop starts up, because that would be essentially resetting the party data that we just set in this function. If that makes sense. Okay, so we'll grab the game context from the adventure model. We'll reset the party state, and then we'll load the party data. And then start up adventure mode. Okay, fingers crossed. Let's give this a shot, see what happens. So we start up, we walk around. Oh, there we go. It's a wonderful day. I wonder why that wasn't... Oh well, it's not the biggest deal. It's just annoying. We walk around, we're in combat mode. We go attack. Attack. Oh. Huh. That's not great. Ah, of course. What am I thinking? Let's go back to the controller. I'm forgetting to reset the return action. Look, we update the game context. There we go. Okay. Yeah, let's give that another go. Okay, we walk around. Hey, NPC, what are you going to say? My hovercraft is full of wheels. That makes sense. Okay, combat mode. Attack. Attack. Uh-oh. Huh. Okay. Ah, of course, of course. Of course, of course. Combat model. We go. Okay, so. There we go. We should save the data. This is complaining, hey, this file doesn't exist. Yeah, it doesn't. Okay, there we go. Take 3, battle, attack. Oh, this is a tricky one. Let me go cast harm. Okay, should probably use our health potion. There you go. Then we load back, and we are where we were before. And then we can keep walking around. We go into another battle. And there we are. Okay, so like I said, we are now at the point, I would say, where this is Turing complete, and it's functionally like it's working. Now, I said there were other things I was going to add, like barrels we could walk up and collect items and things. In the interest of time, I'm going to leave that as an extension activity. It is a good thing. It's pretty similar to the NPCs. Another extension activity, debug the NPCs. I don't know what they're doing. But then, in the next stage, we're going to get graphics into this, and then animations, maybe. And then in the next stage after that, we're going to get music and sound effects. And this will start to become an actual game. Anyway, thanks for sticking with it. It's quite a session, and I'll see you again soon. Bye. Alright, so we're at the stage where we're going to bring in some images. First of all, I just want to quickly talk through some changes that I made behind the scenes. I didn't film these because it's very tedious, but I will talk through it. If we go to the config file, you can see that I've moved all of the named constants from all of the model files into this. And the reason for that is that these other modules import config using a star import, which means that we do not need to preface the constant name with the module name. We don't have to access into the module, we just grab it directly. So that simplifies the code a little bit. And then the second thing I did is I took the model files and moved them into the one file, because some of these classes have a little bit of overlap. So for instance, we have this character class. Okay, that's fine. Also, I got rid of all the getters and setters, just because it was too many one-line functions, made the code base a bit unreadable. So we have the character class, and then we can have classes which inherit from that. So we have, of course, the party member and the enemy party member. And they pretty much have everything that the character class has, but we can define an act function for each of them. And that is where we put the individual code for performing actions. Basically the AI, very simple AI in the case of the party member, and the state handling, action handling code from the game logic. That has the benefit of reducing the number of code lines in the game logic class, and it sort of logically makes sense that a party member should understand how to act, if that makes sense. Another big thing is, if we look at the player class, the player class is pretty similar to the villager class, to the NPC class. So I made a common class called human, which has all the common behavior for both of those, and the purpose of each specialization is just to define the unique aspects of that behavior. So when the player class moves, well, it goes to the superclass, human, and says, okay, go ahead and move by this amount. It does the move there. And then, in addition to that, it also performs its own distance checking to see, should we trigger a battle, and so on. But anyway, so we have that. The player and villager class both inherit from human. And then we have game logic, and if you remember in the previous video, the adventure game logic and combat game logic sort of shared some similar aspects. They both had similar save and load functions for some, for the party and the inventory. So what I've done is I've made this class, game logic, this base class, and that has those common functions defined, and then we can make the specializations, which inherit from the base class, and they just define everything else. So yeah. Anyway, it's quite a bit to look through, but is definitely worth checking that out in your own time. Okay, so on with the show. The purpose is to get sprites showing, and I'm going to sort of dive into the hardest bit first, and that is not character, but animating the sprites as they walk around, right? Because combat is very simple, it's just images, but when we walk around, that's important. So I'll just open up, where are we? I've made this graphics folder in the source code, and if we click in here, we have a bunch of sprites. So for instance, this is the mage. We have 3 walk animations for each direction, north, east, southwest. We don't have northeast or anything like that. Unfortunately, it's just the sprite sheet that I got. And the soldier and the villager and so on. We have this wasteland background for doing battles, and these tiles. Unfortunately, the regular ground looks pretty similar to the radiated ground. So it's a good activity to go and make your own tiles or something. Anyway, this will work just fine for a prototype. So importantly, we need to track 2 things for a sprite. We need to track which stage of their walk animation they're on and which direction they are looking in. So I'm just going to add this dictionary here. So we'll go to the constants in the config file, and down here we can see these directions. Okay, that's fine. I'm just going to add this dictionary called sprite directions, and this is basically saying, hey, for instance, if we're actually pointing in a northeast direction, what should we display? So in this case, I'm just going east. And then for south, southwest, northwest, it's all west. Sorry, these ones here, it's all west, and so on. So that's just a handy lookup table. So then we'll go back to the model, and it's these ones here. This human base class is the one that's walking around. So first of all, we'll just define a variable called step. That'll be the animation frame that we're on, and then I'll make this direction descriptor. So that's just a handy description of which direction the sprite should be facing. As well as that, I'm going to keep track of what speed the player is walking at, because when they stop walking, we want the animation to stop. And that's just a handy way that I found to set that. I did try setting the direction descriptor to none, but then it looked weird because we'd walk along, then we'd stop and turn around and face a certain way, and then every time we stopped we'd turn around. So we'll just keep that speed variable. Okay, so we'll head here and we'll go to the move function. So first of all, we'll just keep track of which we'll keep track of our direction based on where we're moving, and then we'll calculate what speed we're moving at. There we go. Okay, so this is basically choosing the value for the direction descriptor based on the actual value of direction or its signs of its components. Note that if the x component of the value is 0 and the y component of the value is 0, this should probably be set to none, but I haven't included that, and that's just making sure that when we walk, say we're walking east and then we stop walking, our speed fully goes to 0. I don't want to reset the direction that I'm looking. I just keep direction descriptor where it was. So we've got that. So in theory, this should be choosing the direction based on where we're walking and setting the descriptor appropriately. Actually, I just changed my mind. Let's get rid of that line there. We can do all this without setting the direction. Okay. Cool. So, what about the animation step? Well, if we go down to the adventure game logic, actually, go down to move player. So here we're saying, okay, if the player can't move, then reset them, but an if has an else. So we'll say otherwise okay, so we could increase it by 1. That'll be stepping a little too fast. The animation will look weird. I'll go a quarter of a step each time. Take it under mod 3 so that repeats. Goes 0, 1, 2, and then back to 0. Okay, so that's all well and good. We'll just go down to the update, and then here we'll say, well, if the villager can move, then set its step. Okay, so there's another little change that I want to make. If we go to the make player interact, here when we talk to the villager, we set the villager's direction to 0, but we can do a little better than that. Let's say we do this instead. So this dx will be the direction from the villager's position to the player's position. And then what this step is doing is basically normalizing that so that it's either -1 or +1. And we'll do the same thing with dy and then set the villager's direction to those. So essentially, that will be setting it up so that the villager will always look towards the player. Okay, so in theory that should be fine. We can head over to the, where are we? Yeah, adventure view. I kept the view classes separate from each other because they don't have that much overlap. We'll go down to, this is quite a bit here. So if I look at the player, I want this to be a dictionary. The keys of the dictionary will be the directions that we're looking. So if we look north, I want there to be a list of images, 3 images for each of the walk steps. And I'll set the same for the NPC. Okay, cool. So what I want to do is I want to go down, I want to go down into this code and load this. Now what do we have here? Okay, player and NPC are here, so here I'll write the code, and I'm going to loop, so I'll go through the 3 walk cycles and set everything. Okay, so what do we have? So I'm loading this image. The file path is in the graphics folder. It's called Mage North, and then we insert the frame number to that file name. Convert that, and it has some transparency, so we'll convert it in alpha mode. And then, whoops, say OK. We're in the images. This is the player sprite, and then access into the inner dictionary there, and say, okay, this is the north direction, and append that surface. We are going to resize it to 24 by 24 just because that's the sprite sizes that I set in the game mode. And yeah, okay, so we'll go ahead and do the same thing. As you can see, we're setting the 4 directions for the player sprite. And then we'll go ahead and do the same for the villager, for the NPC. If you're wondering, this is from my previous notes before I did the refactoring. Okay, I mean, yeah, there it is. It's very repetitive. That's fine. So, just double checking through there. That is okay, I guess. Let's just close that down, and then we'll get to actually rendering. So there are 2 places where this gets rendered. Once in the once in the map view, and then again in the mini map view. So we'll go to the map view first. Okay, so we'll go to the villager, and we'll say okay. So we'll use that sprite directions lookup, and we'll look into there, and we'll say okay, and I want to get the village's direction descriptor. So we've got that, and then I want to get the image, which I'm going to display. So I'll say, okay, which sprite are we displaying? We're displaying the NPC sprite. Which direction are we displaying? Well, we got that before. We're getting the display direction. And then, okay, we're in that direction. Which frame do we want? Well, let's get the village's step and round that to an integer. And there we have it. So I'll go ahead and split that in. We can actually do almost the same thing down below. So again, we say which direction. Of course, it's going to be the player's direction descriptor. And then in here, we are accessing the player sprite based on their step variable. Okay, so that's fine. Let's go ahead and grab that code and reuse it down below for the mini map. Just double checking all of this. Yeah, this is all fine. And then we'll do the same thing for the player. Yeah, so again, go through that. We get the player's direction descriptor, pass it into the translation dictionary. That gives us something we can put out on the screen, and then we access into that to get the associated image. Now, if we give this a go, hopefully there's no errors, but there will be an issue. Okay. What's this? New width equals... Oh yeah, okay. So scale images isn't going to work properly because... Where are we? Yeah, we're here actually. Because this is simply taking a copy of the dictionary and then looping through it, and that's under the assumption that each of these things that we get, objects that we get when we access into the dictionary, is a Pygame surface, and that's not true now. So let's just go in. Okay, so let's say self images, we don't know, blank dictionary. And then we'll scale the images, and this will take the dictionary, look through it, and then fill in the self images dictionary. So what we can do here is we can go, okay, for image type in the images, and then we'll go okay, so this is just doing the standard work. This will work just fine, and it will insert the surface into the dictionary after applying scaling. Okay, so if this doesn't work, if it's a player or NPC type, then it will be animated. So what do we insert into the dictionary for that key? Well, we'll insert the inner dictionary, and then we'll look through that. So we'll go for direction in. Okay, so remember, this images dictionary that we're getting is fully fleshed out. So if we are looking at a player or an NPC, and then we access one level in, that will give us a fully fleshed out inner dictionary, which has all of this, where are we? Has all of these directions. So then the next loop is looping through northeast, southwest, basically. Okay, and then for each associated direction, we want to create a list, insert that list into the inner dictionary, and then flesh that out. So now we can just loop through. Then we'll just grab this. So now we're dealing with the underlying images. Okay, cool. So that should be working. Let's give that a crack. Alrighty. Oh, what a mistake. Okay, here for image type in self images, well, self images is a dictionary we're trying to populate. That should be images. Fingers crossed, give that another go. Okay, a new error, that's fun. 171. Oh yeah, okay, now that's fine. That is fine. Here, original images, we are accessing that bit one there. And the same down here. Let's give that a go. Okay, very cool, very cool. But we've got a problem. We've got a problem. Okay, so let's go back to the drawing board. It's not a big deal. See here we're stopped, so our speed variable is 0, but we're still walking. So let's go back to model and adventure game logic. This, yeah, these two, move player and update. So we'll go only do this if we're also moving at a non-zero speed. And the same here. Okay, so where was I? Give that a go. Okay, good, we're stopped. If we look at these villages, they walk and then they stop. Okay, left, right, up, down, that's good. Let's go speak to them. Come on, come on. Yeah, watch out for monsters. And see, I fixed the interactions as well. It's good. Although, that's fine. We can fix that up later. Alrighty, cool. So that's fine, and that's actually the hardest part, which is why I wanted to do it first. Now the next parts are a little bit easier. We're going to set the background, and then go into combat mode. So we'll just go to the adventure view. We can close all of this. This is fine. It's actually surprising how straightforward this next part is. So let's get rid of that, because we're going to insert these in. Okay, so let's do the ground. So we load the grass image, and then we insert that under the ground terrain key. There we go. Okay, and then we'll just keep doing the same thing. So for the radiated ground, for the blocked ground, we'll add that lava. And then for the radiated ground, we'll add that other image. Okay, so very straightforward. We're just inserting entries into this dictionary. The dictionary expects these entries to be Pygame surfaces, which before we were filling with colors and now we're loading them with images. It works the same way. And the rendering code just looks into the dictionary, grabs the surface and blitz it. So we can go ahead, run that now. And I mean, it doesn't look great, but for a prototype, it's functional. And you can see in the mini map, again, it's not great, but it's functional. Actually, it looks sort of cool and retro. So the next part is this, working on combat. Again, very straightforward. So we'll just go to the combat view. And we'll go down to, let's go to the map view. So see here we have this create background screen. We'll create background image. So here's what we'll do. We'll go create a temporary surface. And then we'll scale that. So we'll say self background . Okay, good. And again, it's just populating a surface. So we can go ahead and get into that. Well, fingers crossed this works. And there we have it. We got a background image. Cool. Good prototype. So then I want to add sprites for these, these monsters and players. So I'll just go close that down, go to the renderer, and then to this create assets. And again, we can just completely remove that. And then we'll do the same. So Again, it's a two-step. The first step is to load the file. Remember to convert alpha because these images have some transparency in them, and then scale them to 32 pixels by 32 pixels. And of course we can get rid of these modules. Okay, cool. So that is looking fine. We can go ahead and run that. Okay, so there are characters. We're fighting a rat, just a single one, so we can go ahead and attack it. Still another one. Okay, yep, fair enough. Attack that one. It dies. Come on. Okay. Just want to get to a bigger battle. Okay, so I just wanted to note another thing. You might see here, when we attack, there's a delay, and now the health decrease is applied at 45 frames, so when the other enemy gets knocked back. So let's go attack this rat here. We swing, and then the rat dies. Go attack, we swing, and then the monster gets hurt. Oh, that skeleton got a lucky blow in there. Let's give it a health item. There we go. Okay. Cast harm on that one. It's gone. And yeah, this is a lot of fun. So there we have it. As you can see, the demo, the prototype is, oh, anyway, it's almost done. So we've just got one bit left, and that is adding sound effects and music and stuff. And yeah, that'll be it. So look forward to seeing you again in the next one. Bye. Alrighty, so final stage, we're going to do two things. Firstly, we're going to get sound effects, and then we're going to bundle the whole game up into an executable file. Now, I've added this sound effects folder. If we go in here, we have a bunch of various sound effects. That's a sound effect. And we also have some music for walking around and stuff. Okay, so let's open this up, get started. Now I'm just going to do a few little adjustments. This is something maybe to look into at a future point, but I was getting some errors in key press under the combat mode. So we can just pop in here. Okay, so here we're grabbing the mode, accessing the appropriate function, but it's probably a good idea to check if that mode is even in. And we could say, well, wait a second, if the enemy is attacking and we hit up and down, that shouldn't do anything. And yes, that's true, it shouldn't do anything, but that event will still be triggered, so we should check for that and only act in the appropriate case. Okay, so that's fine. Then the next thing I want to do is if we go to the controller in this transition into battle, we can do a little bit more than just going straight in. Let's do this. Let's tell our renderer to save a screenshot. Make this function in a second. And then we'll set up a loop. So we'll say, okay, let's go for 60 frames. So while time is less than 60, and what we'll do each time is we'll tell the renderer to render that screen, and we'll put in a float that goes between 0 and 1. We'll just take the time as a proportion over 60, and I'm going to use this to slowly draw a black wipe over the screen. So we have that, and then what else? Of course, we'll have to increment t, and then we'll have to control the frame rate, otherwise this will pretty much happen all at once. Okay, so there's that. Now let's go to the adventure view and go ahead and make those functions. Okay, so here we have the renderer, and we'll just go right down to the bottom, doesn't matter. Make this function. We'll just use this copy function, which returns a copy surface. Okay, fair enough. Then we'll just go ahead and make the render screen. Okay, so what will we do? Basically, let's fill in a rectangle on the screen. And it's okay, we don't need to make a copy or anything, we can just do it directly. And then save, blit that to the screen. So we'll fill that with black. Top left will be at the top left. And then for the width, we'll take the screen width and then multiply it by the proportion. That'll make it wipe across. And then for the height, let's just go for the full height. Okay, then we can blit that onto the main screen. And then flip the display. Okay, so that should be it. Let's give that a test. So we'll just go run. And then we'll walk over. There we go. And then we have the transition. Cool. So that is looking good. Now back to the sound effects. So we'll just go to the config file. And we'll say, I'm going to use a library for this. The library is called OpenAL, Open Audio Library. If you don't have it, I believe you can just go pip install OpenAL. Oh, maybe not that one. Let's try PyOpenAL. There we go. Yeah, pip install PyOpenAL will give us it, and then we can just go from OpenAL star import. That gives us everything we need. Open Audio Library, the Python implementation, is pretty nice. It's pretty easy to use. The reason I'm using this and not Pygame's mixer module is that Pygame's mixer module sometimes is a little more particular about file formats and things. Seems to work okay, but I'll use OpenAL. Okay, so what we need to do is load all of this, but let's just start with the music. So we'll make a constant. So if you need to, just like OpenGL functions start with GL something or other, OpenAL functions start with OAL. So if you type OAL, you can see all of the, or a lot of the options here that we have, but you can also look at the documentation and that works just fine. So we just put in a file path, and we can put in an extension hint if we want, but the really important part is this returns an audio source. And an audio source is something that we can play, stop, set the volume level and all of that. So we'll just open up, go into SFX, and then that is called Adventure. We don't need to put a type hint here for the file because it can work that out. And then we'll do the same for Combat. Okay. But I might find that when I load this, the sounds might be too loud. So what we can do is we can go for the items. So remember, track is a source, an OpenAL source object. It's these corresponding things, basically. It's the value of the key value pair in the dictionary. But we can, not that. We can go track set gain. It says here this is just anything between 0 and 1. 1 is 100%. Let's set that volume to 50%. Make it, make sure it's not overpowering. And I'm also going to set another property, and that is looping to true. So if I play one of these songs, they will go along. There'll be a small pause and then they'll loop again. And that's fine. I can just manually start and stop them when I transition modes. So let's give this a go. We'll just go to controller and the main loop. So we go adventure main loop. Let's say, okay, when we start this, we'll take the music and play that. And then when this loop ends down the bottom, then we'll go ahead and stop that. And then the same thing for the combat. Play it, and then at the end of the loop, stop it. Okay, cool. There's another thing, and I'll show you this. So let's go ahead and run this, and we can hear that adventure music. Okay, good. Then that stops, we go into combat mode. Now, if we exit, you'll see that we have an error here. Audio library lib. Lib means library, so I don't know what they're saying there, but it's saying we have a device which isn't closed. So what we need to do is just after the app has finished running, we'll say OAL quit, and that will free everything and we'll be fine there. So just run that, does its thing, exit, and there's no error. Okay, cool. So for the next part, it's just a lot of copy pasting because I need to load in all of these sound effects. So I'll just copy paste this. Okay, so we have another dictionary. Again, the keys are strings describing the sound effect, and the values are the various sources as they're loaded in. So let's start with, okay, let's go to the transition into battle. So go to controller, just reorder this. Okay, so when we transition into battle, we want that to occur before the visual effect. So we access into here. Okay, let's give that a shot. There we go, cool. So again, all we need to do is access the source and then play it. Okay, cool, so that is fine. Adventure, that's fine. We could put another sound effect here for like success, but that's fine. Main loop, yep, that's okay. This is all fine. Okay, so then onto the model. There's actually quite a bit here. Let's start with the character. No, character's fine. Right, so the party member. So I want to put sound effects on these actions so that when we do something, what am I saying? This act function will be called at 45 frames into the action. So the first 0 to 15 frames is the player animating, then 45 to 60 frames is the result animating. So essentially, what I want to do is give a sound effect for the result. Now, if we attack, we want to play some sort of damage sound effect. And we also want to do that for the harm spell. So let me just show this. We'll go So I go and attack this one, and that's the react sound effect. I'm going to attack this one, react sound effect. Anyway, that's fine. But then, what if we want to cast a healing spell or use any sort of potion? We'll play, there's another sound effect called heal, which is basically just a power-up sound effect. Okay, that is fine. Then when the enemy attacks, they go ahead and select a character. We can play the attack sound, the react sound. That's fine. So now we should be making sound effects when we get attacked as well. And we look at this human, and yeah, just double checking all of that is fine. Same with the player. So what am I getting at? I want to make sound effect when we walk around. So let's go down to the adventure and then to the move player function. Okay. So here we check if we are actually moving, and then we increment our sprite. We don't want to play the stepping sound effect every frame. That's a bit much. But what we can do is check if the animation has looped over, which means oops, maybe not that. There we go. If the animation frame is looped back over to 0. And if that's happened, then we can go and play the step sound effect. Let's give that a go. Okay. There you have it. We're walking around. But note that the sound effect isn't overpowering because we've reduced the volume. Okay, so that's it for sound effects in adventure mode. It's pretty straightforward. There are other sound effects we could use, but oops, that's all fine. Okay, now in the combat, things are actually pretty good at the moment. Let's pop in. So we can go attack. So what do we need to add in? Oh, by the way, let's go power this guy up. And we have the power up sound effect. We're missing sound effects when the players and the enemies swing to attack. And it would be nice if we could add sound effects to the menu so that when we navigate through, it needs to feel tactile, like we're actually doing something. So let's go back to the combat. Handle key press is where it's going to happen. We'll just skip past that for now. Actually, what am I thinking? We could put the sound effects in the update function, but I'm actually not going to do that. Let's go to the handle, the key press handlers. So let's have a look here. Okay. So here we're selecting an action. Let's say if we go up or down, we'll play, what is it? Over here it's menu move. Okay, so that's the up and down selecting things. And I'll actually put that in enemy select as well. And in spell select, we're going to put it everywhere basically. And item select. And also in member select. Okay, cool. Just double checking. Then we have, okay, action select. So let's say we hit space and we are going to get into attack mode. Oh, actually, it's enemy select. We don't have to play anything in these cases. Actually, I changed my mind. Let's play the menu select sound effect because we selected a menu item. Enemy select, that's a little bit different. Spell select, yeah, that's still inside the menu. So when we select that, we'll play the menu select sound. Yeah, item select should be the same. Okay, but in these other cases, we are selecting either an enemy or a friend. Let's go play the act sound effect. Okay, cool. Let's give that a go. Okay, so we have menu select. Let's say we want to attack. There we go. Okay. Let's say we want to cast a spell. Thinking. Okay. That's fine. Let's give the enemies acting sound effects as well. So just pop in here. Let's put that in the update function. So let's say there we go. Right. So at the 0th frame, we play the attacking sound effect, and at the 45th frame, we play the resulting sound effect. Okay, cool. Right, let's give that one more go. There we go. Okay. So now I have all the sound effects, and yeah, so now we are pretty much at a stage of completion, or at least as far as this prototype goes. So I was trying to model basically a short prototype that we can make in a week or two, doing a little bit every day. Okay, so that's fine. That's good. Now let's look at packaging this into an executable. Now, why would we want to package this into an executable? Does it improve performance? No, it doesn't, as a matter of fact. But what it does do is it grabs the Python interpreter as well as any other libraries that we use in our project and bundles them into one executable, so that if we pass this around, the person running the program doesn't need to do all the pip installs. I mean, imagine you're distributing a game, but you're distributing it in source code, and you have to write a long comment, a long doc string of pip install this, pip install this. It's a bit much. So there's a package called PyInstaller, which you can see here. I've already got that. No problem. The way we run this is we say, okay, PyInstaller, and then we have our entry point to our program, which is this main.py in our case. So we'll run this. Okay, there we have it. Now what this package has done is basically sniffed through our project, grabbed any dependencies, and bundled them together. So if I open this up, it's made 2 new folders, build and dist. Build, not super important, it's just a whole bunch of temporary information. Dist is distribution, and this is the final thing. So as you can see, we have all of these packages that our project relies on, as well as all these DLLs. And we go down, there's this main.exe. Now this is about 4 megabytes or so, and you can probably imagine it's pretty much just the Python interpreter. Now this is a bit nasty. We might want to distribute it this way, but instead let's delete all of this and try that again, and we'll set an option. So we'll go py installer F. Not sure what the F stands for. Usually in terminal commands, F stands for like force, but I believe it's file. So just bundle into one file. Anyway, point is we just have to use this. So we run this and it will do the same thing, but bundle it all into one executable. There we go. Okay, so we can open that up. And again, we have build and dist. We can just get rid of build. That's fine. It's just temporary info. Go into dist and we have this main.exe. Now, if we run this, it does nothing. And the reason for that is this is 26 megabytes. It's just the Python interpreter and the libraries all sort of flattened together. So what we can do is just bring it outside so that it has access to all of these files that we're using before. Then we can go ahead, delete that. That's fine. Run this now. And then we get our executable. And it's linking to those files. Quick battle. Oh no. Ah. Come on. Can I do it? Okay, cool. So that is it. Thanks for sticking with it. Hopefully, you know, if you've done this project or you've done one of your own projects, hopefully this course has helped you to be a little more confident and start thinking about code and systems. And yeah, hope you had fun. And yeah, that'll be it. Cheers. Bye.